Testing, testing. Hope my audio is okay. We definitely need some more and perhaps different sound effects. I need to go check what the unapologetic sound effects are because some of those are really good. Howdy, howdy, everybody. Hope everybody's having a good day. Welcome, welcome. Welcome. Hello. We're just going to wait for some people to trickle in and then we'll get started. Oh, dang it. I forgot to put socks on. Guess my feet will be cold this morning. Oh well. I guess I'll be okay. Yeah, I mean, if you're in UTC +8, then it's not morning. From helping MAGA deconstruct, can your PhD hold up to nuh-uh today? Oh, we'll see. We shall see, and the answer is probably no, apparently. Go get some socks? No, we did just start the live. How do you respond to the allegations you look like human serpentious? That I haven't seen that media, so I can't comment on it. Show the grippers. What are the grippers? You mean the feet? No, I'm not going to show you my feet. Bunch of weirdos. All right, we do have some guests in the guest box, so let us get started. Oh, actually, I have to jot something down really quick. To mark that today is March 11th. All right, let's talk to Matthew. Matthew, how's it going?
Bro, I did not expect, man. Like, can you show your feet?
No, I'm not going to show you my feet, weirdo.
Damn it.
Don't be weird. Why are people weird about feet? I mean, I know why people are weird about feet, but still, don't be weird about feet. I think I spoke to Joss last time. Let's just check if he's a flat earther. Joss.
Hey.
Joss, what shape do you think the Earth is?
I've been pondering it for a while. As I said in the last live, and that was a wild one, the 6,000 years thing, I see sunlight strike the underside of clouds in the mornings and the sun sets. Yep. So it's round, it's globular. Okay. There's no doubt about that.
I'm glad we agree. Then I gotta let you go, though. No, but you said it's globular. So you've been had. From C-Bar, get a smoke alarm chirp. From C-Bar with the $2. I will not. And from just some guy with the $2, hashtag socks for Blitz 2K26. I'm actually part of the Awesome Socks Club. So I get a pair of socks every month, a new pair of socks designed by an independent artist, sent every month. I have plenty of socks. I just forgot to put them on this morning. That's all. All right, let's talk to Mr. Swagtastic. Mr. Swagtastic, how's it going?
Hi, Blitz. Sorry to ruin your day, but I just wanted to say I love you, man, and stay strong.
No, I refuse. I will not do that. I'm actually going to be weak. I'm going to be extra weak now because you asked me to specifically. I kid. From Gretchen with the $3.11. Happy 311 day, Blitzy, and to all who separate. I get that this is a reference to something. It's like a band, right? But I still have no idea what it is. So, appreciate you. But thank you, Gretchen. Joss, you think that the Earth is a globe. So you can't come up, Joss. Okay, actually I'll bring you up just because there's nobody else in the guest box and, Joss, look.
Wait.
You think it's a
You're
globe.
scientist.
So what's
I think it's a globe, but
Yeah?
I think the way the person who created it, he sees it as flat. Because all the text in the Bible, he speaks to it and interacts with it as a flat plane. So
Okay,
do you think
does he see it
it could exist
incorrectly?
in two states?
No,
What?
it can't be both. So does
well,
the
if
creator
he's in
did the
one
creator create
dimension-
it incorrectly, or view it incorrectly?
No, he can see everything at once. It's like,
That doesn't mean that it's flat.
well, if you look at the language, you'll see that.
I understand that it
whoever-
says that it's flat in the Bible. That it definitely implies that it's flat in the Bible. I understand that. It's just wrong.
Yeah. But I mean, if we are in two different dimensions, you know what described it best? It's that movie Interstellar. When they were approaching the wormhole, the pilot, old Cooper, he was surprised to see it's a sphere. So the guy described that when you put a hole across two places in space, it's a three-dimensional hole.
So a four-dimensional being would not see the Earth as flat.
Okay, explain. Do you think it?
Because the Earth still has curvature.
Well, look at the flat Earth model. It
doesn't have curvature.
It doesn't have curvature, but if it's got a center point, which is the North Pole, and then the ring.
So the
ice wall
surface of our Earth has curvature.
Correct.
A four-dimensional
Correct, it does,
being
it does.
would see it as having curvature.
Do you think so? I'm not sure. We don't know.
So curvature is objective. This is not a subjective thing. Curvature is an objective feature of the geometry.
Okay.
So, I mean, like, if the creator that you believe in says that it's flat, then the creator that you believe in is wrong. Joss, I am going to let you go, though, because we do have a proper guest, I think. We have Jonathan Jordan. Jonathan, how's it going?
Hey, what's up, dude?
Not a whole lot. Jonathan, what shape do you think the Earth is?
It's round, but it's flat.
Can you elaborate on that a little bit?
All right, man. I would love to. All right. So if we look at that little flat Earth image right there, you can Google any flat Earth. Just put in flat Earth, you'll come up with all the same pictures. All right. But if you also Google how much of the waters has actually been discovered. Now this is where everybody loves to try to get me on like satellite images.
Jonathan, just to be clear, do you think that the Earth is like spherical shape and also flat, or do you think that it's like circular and flat?
Well, technically, it's not really either. It's not like oval or round. We'll get back to that here in a second, though.
Well, you said that it's both, right?
Yes, and I'm going to describe.
So I was asking,
why,
like, because you said it's round and flat, right? So I'm just curious what you meant by round.
All right, so if we take a round ball, right, split it in half. You got the upper atmosphere, which is
right. I'm talking about the Earth part. Right, I'm not talking about the atmosphere.
Right,
I'm talking about the Earth part.
The Earth itself. Then you got the round part. The other part that takes away from the other half right there.
I'm talking about like the dirt part, the ground part. What shape is the ground part?
Yeah, you see that little dirt pile that's in your picture right there? It looks like a mountain formation underneath the Earth.
Sure.
All right. Now imagine all that water. The other half does the water part.
Okay, Jonathan, do you think that the Earth is shaped like the picture behind me?
No.
Or above me? Okay, what shape do you think it is?
But in a sense. All right.
Okay, what shape do you? So do
right,
you?
You got the atmosphere, right?
Look. I'm asking about the ground part, the part where the oceans and the continents are. Do you think that that's flat, or at least like planar?
All right. Give me 10 seconds then. All right. You got the atmosphere, and then you got the waters right there. You got the land on the waters. You have that ice circle, and then underneath that, right there, where you see the grayish black, it looks like a mountain, like a core area. Imagine all that still water, but it's still land underneath it. But there's water as well. Wait,
there's land underneath it? Underneath
right.
where?
You
underneath
got
what?
Imagine a circle, right? Half that circle is where the Earth is. Above that, the dome right there is air. Down below the other part of the dome would be water and Earth itself.
Okay, but you think that we're living on a flat bit in the middle?
Yeah.
Okay, so you think the Earth is flat? Fine.
Now, the only reason I say that is because if you think of like an atom itself, all right, think of an atom. All right, what's inside the atom?
What does this have to do with the shape of the Earth?
I'm gonna get to it. I promise. What's in explain an atom to me.
I don't think I'm going to do that. Instead, I think we should talk about the shape of the Earth.
All right, then I'll go ahead, man. You got the nucleus inside. All right. You got the neutron, and then around it, you got protons and neutrons. I'm sorry. Neutrons, electrons. All right. Then you got the neutron that's inside. Am I correct or am I wrong?
You're wrong. What does this have to do with the shape of the Earth?
Because if you look at an atom compared to the Earth itself, if we can look at it like we're living in a type of atmosphere, all right. Everybody, all these people, flat earthers, said, "Well, where's the water go? Where's the water go?" So why couldn't it be impossible, to think that the bottom of the Earth itself, right there, is water and Earth?
Okay, great. So why do you think that we live on the flat part in the middle?
Well, I mean, when we know more about space than we do our own oceans. When we look at our own oceans, only
that doesn't really answer my question. Why do you think that
been discovered?
Why do you think that the part that we live on is flat?
Because that's what I'm saying.
I don't understand your answer. Right. Can you elaborate a little bit more?
How much of the ocean has been discovered?
All of it. We've mapped the entire thing.
No, we haven't.
Yeah, we have.
We have mapped it from a type of, you got the satellites and things like that, but it doesn't give. There's not an accurate description of how much is. If you don't believe me, please Google it. Prove me wrong.
We have 100% coverage of the oceans up to like 5 kilometer resolution.
If you don't mind, prove me wrong.
We have 100% coverage up to 5 kilometer resolution. Now, what you're talking about is sub 5 meter. What you're talking about is sub 5 meter resolution over the bottom of the ocean. That we don't have because, it's kind of a waste of time. Yeah, of course it is. What does this have to do with the shape of the Earth?
How much has the ocean been discovered?
Can you answer my question? What this has to do with the shape of the Earth?
The shape of the Earth, because if you Google flat Earth right now, if you Google flat Earth, and you would see all these images, just like that's the image right there above you. Not one image describes water underneath that and an atmosphere above that.
Can you explain why
it's possible for anybody to
hey,
understand?
Hey, Jonathan,
why can't you have a round Earth?
Jonathan, are you like
theory
Jonathan? Are you currently like reorganizing your garage?
Oh, I'm sorry. Let me put my earbuds in because notice the wind against the plastic. All right, is that better?
Hopefully. Are you outside or what's going on? What's all that background noise?
That's the wind.
It is no better.
Yeah.
It is no better.
No better?
No.
All right. I'm going to jump off here then. I apologize for all that. It's just the wind, the plastic.
What plastic?
It's rattling. I'm on the back porch.
Oh, okay. All right, Jordan, feel free to come back when the wind dies down. Jonathan Jordan. His first name was Jonathan, my bad. That was something. All right, let's bring up Muhammad Hassan. Oh, let's make sure that I didn't miss any super chats. We did. We missed 2. From Floorknob with the $2. I think you wiped out all of the flat earthers. Well, one could hope, right? And from Floorknob again, what do you believe the 4th dimension is? There isn't, as far as we can tell, we have no evidence that there is a 4th spatial dimension. There is there are 4 dimensions of space-time. This would include, 3 dimensions of space, 1 dimension of time. And we have $2 from Detson. FLERFS are all trolls. They are not, unfortunately. From Urso with the $10, Caleb brags about you being scared to debate him. I would really like to see you destroy his worldview. Well, I have debated him in the past, and then I found out that he was a Hitler-supporting neo-Nazi, and now I don't talk to him. Because why would I talk to a neo-Nazi? All right, let us bring up Muhammad Hassan. Muhammad, how's it going?
Hello, I'm fine, thank you. How's it going with you?
I'm doing all right.
I am with you. Earth could be flat.
Muhammad,
Earth could be flat for one reason.
Muhammad, I'm asking you, what shape do you think the Earth is?
I think it's flat because, or 71% from the Earth is flat because the water is level.
Because the water is what?
Learn that 71%.
Sorry, because the water is what?
Level.
Oh, why do you think so?
Water will find, because the water right now in my cup of tea is level. And
when you say level, what do you mean?
And in a river. I mean the top of the water have to be leveled.
What do you mean by
it's
level?
The water level.
What do you mean by level?
Level means in the same line, can't be curve.
Oh,
level.
Okay. So why do you think that because the water in your cup looks level, because the water in your cup looks straight, that the water in the oceans must also be straight?
Yeah, that's
why
100%.
No, I'm asking you, why do you think that that's the case? Why do you think that because you can't see a curve in your cup of water, therefore there can't be a curve in the ocean?
Yeah, because that's the water itself. The basics of the physics of the water itself.
What's the basics of the physics of the water itself that says that it's always straight? What property of the water makes it do that?
The water will find its level with the other water.
What law of physics is that?
You put it in. Whatever contain you put the water in, the water will find its shape together.
Yeah, and its shape doesn't have to be straight. It can be curved.
The top of it, the top of the water will be the same level in the same other dimension. If you put any kind of tube or something, the water will be the same level. That's why we're using the same
Muhammad.
The water.
Muhammad, I think you're a little confused. So water doesn't become straight; it becomes curved exactly at the radius of the Earth.
No,
Sorry, that was poorly explained. But it becomes curved exactly in line with the equipotential of the surface of the Earth, or of the gravitational force of the Earth. And so what that means is that the surface of water will match the curvature of the Earth precisely. And so because the Earth is so big,
doesn't happen in my cup of tea?
it does. It's just your cup of tea is very small. So the curvature of the Earth is very, very minimal on a scale the size of the cup of tea.
Mr. Blitz.
That's Dr. Blitz.
The sea is not small. Dr. Blitz.
There you go.
The sea is not small.
The T is small. The ocean is large, which is why the ocean's curvature is quite large.
I'm talking about the sea.
Yeah. So the sea, I understand the sea is large, and therefore the sea will have more appreciably noticeable curvature than the cup of water. Yeah.
You notice any on the sea?
Yeah.
You have any photo with your background is the sea, and you count the right side and the left side and see how many the shape is. Bring any photo right now.
I can show it for yeah. Let me show you.
And show
wait. So would land count? Does it have to be the sea?
Speaking about the sea here.
Okay. I can probably find one.
We're talking about the water, and my answer is 71% from the Earth we live in is water, and because of that, 71% is.
So I can probably find you one, but the point is that you don't need to see side to side curvature. You can see front to back curvature.
It means the shape when it's disappear. Is that correct?
I don't understand what you just said. Can you repeat it?
No. If I am right now standing in a short. And I'm seeing a shape traveling away. The shape starts to disappear right now because
that is true.
Away.
That is that is true because it goes behind the curvature of the Earth. However, what I was talking about is how
listen to me.
Please.
Listen to me, very careful, very nice.
Sorry, I was trying to address what you were saying. So
thank you.
The point is
the shape is going to disappear because it's going to under the curvature.
So look.
It's going to go.
I wasn't talking about the surface. I wasn't talking about things going behind the horizon. I was talking about the fact that the horizon is lower than eye level.
In that case, the shape when it's going away, it's disappear because it's going down. Is that correct?
Why is the horizon
That shape going
higher
down.
than why is the horizon lower than eye level
I'm
if
not
the Earth
speaking
isn't
about
curved?
horizon now. I'm
I
speaking
am.
about the shape, but it's disappeared
I
from my
am.
side.
The horizon is
I'm speaking
dictated
about
by
that
the
shape.
shape. I understand
It
that you
means
want
the
to talk
shape
about the
going
shape.
down.
The horizon, the shape of the horizon
Is
is
that correct?
relevant for the shape of the Earth. Yeah.
I'm not speaking about the horizon. I'm speaking the shape.
The
Now,
horizon
the
tells
course
you
of the
about the shape.
The shape disappeared.
The horizon tells you about the shape.
The shape, the shape.
I'm sorry. You're saying ship.
shape,
I'm not
not the
talking
shape.
about ships. I don't know why you brought
Not
up
the
ships
shape.
when I didn't bring up
I'm
ships.
speaking about the shape.
Wait a minute, hold on.
Listen to me. I bring the analogy of a ship on the sea, traveling away.
I'm not talking about ships.
What that is? I'm speaking about the water, the sea.
Yeah, I know. I'm talking
Yes?
about. I'm
And
talking
I
about.
told you,
I'm talking
shape
about the sea.
disappeared after some
Talking
time.
about the water.
Can
right?
you hear me, please?
I can hear you. I don't know
Okay,
why you're
can you-
not. I
can
don't
you
know
hear
why
what I
you're
said?
addressing
One
something
sentence.
I didn't bring up.
No. I bring it up to you.
You didn't.
because we're
You
talking
didn't
about
bring
the
up
water.
ships.
And I'm talking about.
You didn't bring up the
I
front to
told
back
you
curvature.
ships.
I brought up the front to
Okay.
back curvature.
Okay, but no matter who bring it, I am now on the shore, and I'm seeing a ship going away. That ship gonna disappear after some times because you think it's going under the horizon, yeah. And in the same logic, when the ship coming,
No, it's
to
not
me,
going under the horizon. That's not
it's-
what I think. What I think is it's
where
going
going?
past
It's in
the
the same
horizon.
level. And it's going past the horizon means it's flat.
No,
can see
there
it. It's
there
still
is no
there.
past the horizon
Why?
on a flat Earth.
There is no curvature in that sea. We said it's the water will bend. Water not bending.
You keep saying that.
The
Why
water
should
not-
anyone think that it's true?
You keep saying because if it's true, that ship disappeared because it's going down, and when it's come out, it's come up. It's have to climb the sea, and that's impossible in physics. It's what?
Sorry, what physical law
never
does it
going
break?
Down. Yeah.
What-
Why? How the water will
What
climb? The sea?
physical law does it break?
Tell me how the water will how the ship will climb the sea.
It
You
doesn't
said
have
now
to
it's
climb
going down,
anything.
it's
It's
easy.
following the
Yeah,
gravitational
that's
potential.
perfect.
Yeah, it's following the gravitational potential. So its altitude never
It
changes.
means the water will be level there. The same
Level
level
doesn't
in the
level
water
doesn't mean
where
flat.
Level means level.
It doesn't mean flat. You can be level and curved.
No, level and curve doesn't make sense.
Level just means at the or following an equipotential with regards to gravity. That's what level means.
No. It's
No,
called the water
yeah,
level.
no,
We use it to
no,
measure anything to build
no.
anything. No what?
I
Have you
was-
ever
I was
see
just
a shape
mocking
of
you.
water level?
Sorry, one more time.
It means the shape when it's disappeared because I can't see it. It's not because it's going down.
I know that you
No
say
bending
that,
in
but
the
look,
water.
can you address the thing that I actually brought up? Instead of ignoring
It's
it.
not sunk. The ship not sunken on the
I'm
sea.
not
It's
talking
arrived
about
at the
ships.
other
I was
shore.
never talking about ships.
But
Can you
you're
address the
talking
thing that
about
I brought up?
The sea. No, I'm talking about the sea.
No,
which
you
I
don't
brought
want
up,
to address the thing that I
water.
brought up. That
You
seems that
said
checks
the
out.
sea
Of course
is
you would want to
bending
dodge
water.
that.
No, and I'm telling you the water is level.
Okay, so
But you're
if the
telling
water
me,
was
no,
level,
you can notice.
if the water was level,
the water
why
is
is it? Listen with your ears, not with your mouth. If the water was level, why is it that the line where the water meets the sky is lower than eye level? Why do you have to look down to see where the water meets the sky?
Actually, you don't need to look up or look down. It's
You
going
do.
with your.
This is
level.
measurable.
Wherever your eye is, it's the same level.
Oh no,
Yeah, I
that's not
know,
true.
but I'm
We
telling
can
you,
measure this.
it's
We
not
can
down.
measure the angle. We can measure the angle down that you have to look in order to see where the water meets the sky.
When you fly on an airplane, you see the horizon flying with you. going
Oh no,
up
no,
with
no.
you.
When you're
Is
in
that
an
correct?
airplane, the horizon is a few degrees below eye level. You can measure that on an airplane, actually.
Few degree
Yeah.
under, yeah.
Yeah, it's
Under
below
the
eye level.
And when you are standing in the earth on land, how degree?
It's
Too much,
very, very,
yes?
very, very minimally away from eye level. But that's why
It
in
means
an
nothing.
airplane. That's why we
Could
go
be
to an
nothing, yeah.
airplane to see the effect. So the difference, the angle that you have to look at depends on how high above it you are. And so if the Earth was flat, if it was genuinely flat, then you should never have to look below eye level to see where the
So
water or where the
I'm
land meets the
speaking about
sky.
the water.
Yeah, we are talking about
Forget
the water.
about Earth now. I'm speaking about 71. Yeah,
We are talking
71%
about the
from
water.
this
Yeah,
Earth.
we're talking about the water. You have to look down to see the water from an airplane. Why do you have to look
How
down
do you
if the
think
Earth is flat?
They say Everest is the tallest mountain, yeah? It's about 8,000 meter.
Mm-hmm.
8,000 meter from what?
It's from sea level.
From what?
Sea
8,000
level.
meter
Yeah.
from the bottom?
It's from
the
artificial sea level.
Why you said sea level?
Because
Why you
level
said
can
sea
mean
level?
curved.
Because the sea is level.
You know, level can mean curved,
No.
right? Level just
Sea
means
level.
level just means aligned with an equipotential of the gravitational
Estimate.
pull of the Earth.
Okay. This mountain in Himalaya
Is there like a
counted by the sea level?
Is there just like a language barrier here,
second,
or are
one
you just failing to listen? Like, what's going on?
No, I understood you exactly.
Okay, so can you answer my question? Why is it that you have to look downward to see the ocean, to see where the ocean meets the sky from an airplane?
Because you use glasses. Because you use glasses.
Because I use glasses?
I don't see.
You don't. This
Yeah,
is
you
something
have-
that you
you
can
have your
measure. It has
eyesight.
nothing to do with my eyesight.
Okay, I'm telling you.
Can you answer my
just-
question,
you just
please?
said is why you look down.
Yeah. Why is it that the
You said
angle?
why you look down to look.
Why is the
Yeah.
horizon where the ocean meets the sky? Why is that lower than eye level?
Now we just agreed, me and you, and from the top of from airplane or from the land will be just a little.
Yeah.
Nothing.
Why is it lower? I'm asking you why.
Why it's lower?
Yeah, why is the ocean, where
Because
the
your
place where the ocean
eyesight-
meets the sky, why is it lower than eye level?
Never. Your
Oh,
eye
but you
will
can
lie
measure
to
this
you.
directly.
It's
In
the same
fact,
level.
I've measured this directly.
How lower? How much lower?
From an airplane, it's a
When
few
you are
degrees.
Land.
From an airplane, it's a few
And
degrees.
when you are in land, how many
I
degrees?
haven't measured it
And
from
when
land.
you are standing on land.
Why can't you
How
answer my
many
question
degrees you
about
think?
from an
If
airplane?
From airplane,
Yeah, from an airplane,
No,
why is
from
it a few degrees
4,000
lower than
feet.
eye level?
from the airplane,
Yeah.
because you're flying high.
Why
Because
would
you're
that
flying
mean
high.
that? Why would that mean that the ocean, the place where the ocean meets the sky, why would that mean that that's lower than eye level?
The ocean never meets the sky.
The ocean never meets the sky?
Where it's meet? Look
That's
from
what the
your
horizon
window
is
right now.
called.
Okay. Look from your window.
There's
now,
got to
and
be
you're
like
gonna
a
find
language barrier happening
clouds.
here. Nobody can be this
No.
dense.
You're gonna find the clouds touching the air, the land, and then the cloud never.
That's a
touch
good
the-
point. Yeah.
From
So
your
why
window.
why does
Yeah.
why does it look like why is it that like you can see the
Because every
Sorry,
time
I wasn't
thing
done
is
with my
far away,
question. Do you
think
want
it's
to want me to
going
answer
down.
the question, or do you want me to ask the question, or do you
Go
just
on.
want to answer it before I ask it?
Go ahead.
Why is it that at
Go ahead.
sunset you can see the light on the bottom of the clouds?
Yeah, because sun coming.
So are
Because
you
the
telling me that
cloud
the sun is
hides.
below the clouds?
No, because the sun is high, can see the cloud highs, can see the sun before you.
Wait, so why is it that the bottom of the clouds are lit up but the top are not?
Yeah, because you looking from the down. Because you looking from because you as observer looking from down.
I mean, you can see that
got
the
it?
top of the clouds are not lit and the bottom of the clouds are lit, which
Yeah,
means that
they're
the
not.
light source is below the
Because the
clouds, right?
source of the light coming from because the source of the light come from one side, and you are the observer.
So I
It's
just
now
got to double
you
check something.
create a
I'm
triangle.
gonna draw a diagram and maybe we can go over this because I'm a little bit confused. So
Go on.
let me show you. Let's draw a diagram together, okay? So here, oops. Sorry, one sec. I always end up moving something on accident. So here we have a paint. So I'm gonna draw the ocean. Be blue. So here's the ocean, right? The ocean is flat in your view, right? So here we have the ocean. And then I'm going to draw a little cloud. There should be a little cloud. Okay, there's no cloud thing. I'll draw it freehand. So here's a cloud, right? Or let's put it over here. And then let's say that there's some land over here. Okay, right. So there's the shore. There's the cloud. And let's put me. I'm over here, right? I'm on the land right next to the ocean. So why is it that at sunset and sunrise, this part of the cloud is lit up with yellows and oranges, but the top of the cloud is black and gray.
Because you're looking from down. You don't
So-
look from the, you never see the
So
top.
why doesn't, I mean, you can see the top of a cloud. I don't know if you've
How?
I don't know if you've ever seen the top of a cloud before, but you can absolutely see the top of a
Unless you
cloud.
have a mirror, unless you have a
You don't-
mirror on the sky.
Look,
how
so
you
I
look
can
the
see,
top of the cloud.
I
You
have
can
direct
see
line
the
of
other
sight.
side of the moon.
You seem a little confused.
can
I
see
have
the
direct
other
line
side
of
of the
sight to
moon.
this part of the cloud, right? Like I can see it directly.
Then you can see the other side of the moon.
But why isn't that side of the cloud lit up? Why is it still dark?
You
But
see-
the
you
bottom
see
of the
one
cloud,
down because you are the observer.
why is the bottom
You
of the
are the
cloud
observer.
lit, but the
just
top of the
make
cloud is
sun-
dark?
You make the line. Yeah,
Why
you
is
make-
the
you make
bottom
good
of the
line.
cloud lit, but the top of the cloud dark? Where's the sun in this picture, do you think?
Put it.
Well,
I think
that's my
the
question.
other
Do you think
side-
so?
the
It
right
seems
side.
like the only way to make sense of this, and I have to make this bigger. Sorry.
Oh, put the sun. Show me where
I'm
the
going.
sun is.
I'm going to. It seems like the only way to make sense of this picture, and obviously not to scale. It seems like the only way to make sense of it is for the sun to be over here.
Okay. That's right. It means the top you make it in
Right. So you
black,
think that the sun is
in
lower than the
You
clouds?
can't see it.
Do you think that the sun is lower
No.
than the clouds?
You, the observer, it's the problem you are. You are lower than both the clouds and the sun. And make the line now from the sun to your eye and to the cloud.
Yeah. So
At any point.
yeah.
make
Well.
make that
Yeah. So
triangle,
now the sun
Yeah.
rays can get
make
directly
that
to the bottom of the
triangle,
cloud,
And now you
Right.
know where can you where
but
you
they
see.
can't.
Yeah.
They can only get to this part of the cloud, right? They can't get to the top of the cloud, which is why the top of the cloud is dark.
I know. And you cannot.
So it sounds like what you're telling me.
The top of the cloud.
So are you telling me that the sun is lower than the cloud?
No.
Well, if the
No.
sun is not lower
You're-
than the cloud, if the sun was up here, right? If the sun was up here, if it was higher than the cloud, then I
Yeah.
would think that that would mean that the top of the cloud would be lit, right? See how it can reach
That's
the top of the
correct.
cloud now? So why is it that only
But
the
you
bottom
cannot
of the
see
cloud
it.
is lit,
You-
but the
you
top
will
of the cloud
imagine
isn't?
It's LED. Yeah, you will imagine, but you cannot see it. You can. You have no the sight to see it.
Oh,
look
you know
your
that
eyes
you can
where-
see the tops
how
of
ca-
clouds, right? And you can see the bottoms of clouds by looking at them.
No, you see one side, like the moon. By the moon, you look at the moon and you see one side of the moon. You cannot see the other side. If you want to see your palm hand, you can see your back hand.
So look,
Is
I
that
mean, like from my perspective over here, and I can't believe that we're doing this, but from my perspective over here, I can see this part of the cloud, right?
Now I want you now to draw a fly in a top. like
Wait,
the
hold on,
same
hold on.
level of the sun.
Before we change
You're
topics, I can
flying
see
now.
that I can see the front part
No,
of the
I
cloud
want-
here, right?
Okay. If you fly with airplane, this cloud will
Can
be
I-
under
can I
you,
see the front
and
part of the cloud over
conversation
here?
will be different. No, if you fly, yeah, if you use an airplane. And
Wait a
you
minute,
are
hold
on
on.
top
Can I see the front part of the
that
cloud here?
I can't tell you how you see or not you see. Your eye.
Use your brain.
No, I can't see. Yeah, my eye.
Can I see the
cannot
front
and
of the
it's not
cloud
you.
over here?
You see whatever you want. I cannot see. If I am
I
in
can
that
see whatever I
position,
want.
can't.
Wait, so you can't see the front of clouds, is what you're telling
No,
me?
you might be seeing something. I can't see it.
So you can't see the front of clouds?
You might have a different eye. My eyes can't see that the top of the clouds.
So okay, so
Yeah,
hold on.
my
Let me.
eyes can't see that. You're
I
asking me,
gotta
can
show you
see?
something.
No.
One sec. Let me pull up something else. Just so then we can, talk about something real.
If you put the same photo and you imagine you're flying now, and this cloud under your airplane, you can understand where you getting where you
One
getting
sec.
wrong.
One sec.
Because you make yourself observing that from land.
Chill.
But if you're
Chill.
flying
Chill. Hold
in
on.
a jet, and
Chill.
I'm chilling.
Okay. So what's going on in this picture here? See how you can see the top of the cloud and it's not lit up, but the bottom of the cloud is lit up?
yeah. I can
Okay,
see the
so
photo.
we agree that you can see the top of the cloud, right? We can see the top of the cloud up
No.
here,
No,
and
no,
we
no,
can see
no,
the
no.
bottom
I
of the
can't see
cloud
top
here.
from the- No,
And the bottom is lit up and the
of
top
cloud
isn't.
in our blind side.
In fact, in
No, no,
these
the top of
clouds,
the
the
clouds
bottom
in
is
our
lit
blind
and the top
side.
is not. In this cloud, the
Blitz,
bottom is
the
lit and
top-
also the left is lit,
You
but the
don't
top
hear.
is
You
not.
don't hear anybody. the top of the cloud is hidden from my side and your side. You understand this? You cannot see now the top of the cloud. We see in the bottom of it and one of the sides.
So why is the part up here all gray, but the part down here is yellow?
Because the sun is the other side.
Yeah, so why is the sun able to reach the bottom of the cloud if the sun is above the cloud?
Now it's in the shadow. It's because now this cloud in the shadow.
It's in the
of
shadow.
the cloud.
What is it in the shadow of?
Other cloud.
Oh, so there's a cloud behind it that's blocking it? Is that what you're telling me?
No, the same cloud. The same cloud.
Okay, so there's no shadow. There's nothing blocking the bottom of the cloud.
Like your house. Like your house in the east. It's sunny, but from the west side.
So there's nothing blocking the bottom of the cloud.
In the east blocking it.
Right. So there's nothing preventing the light from getting to the bottom of the cloud, right? There's nothing in the way. It's not in the shadow of anything.
Yeah. It depends. If you are now in the top of the cloud,
that means if the sun was above the cloud, then the bottom would be in the shadow, right?
No, that's correct. Yeah.
But the bottom is not in the shadow, which means that the sun cannot be above the cloud.
Where? Show me where is the bottom not in the shadow.
You can see it. It's the part that's lit up. Right here. This is not in the shadow. This part's not in the shadow, right here.
In the top of the cloud, and you will see the light.
We agree that this part's not in the shadow, right? Is this part in the shadow? This bottom bit?
Anyway, I know you think the Earth is flat.
Bro would never answer that question.
No, I am agree the Earth is flat.
Okay.
I don't understand why you are.
So is the bottom of this cloud in the shadow?
Do you want to know the shape of the cloud?
Is the bottom of this cloud in the shadow of the sun? Or in the shadow of the cloud?
No, the bottom now.
Okay, so it's not in the shadow. But if the sun were above the cloud,
it's light in the front of your eye.
I agree. If the sun were above the cloud, then the bottom of the cloud would be in the shadow.
Yeah, you will see.
So by modus tollens, okay, hold on. We've gotten you. We've ladies and gentlemen, we've got him. All right.
We got what?
Here we're doing a modus tollens here.
Going on.
We're doing a modus tollens. We got to do it. Okay, P1. If the sun is above the clouds, then, and the Earth is flat, then the bottom of the clouds should be in the shadow. You've agreed to this. This is something that you said is that you believe. Second premise. Sorry, that's a typo. It's not about, it's above. Second premise. The bottom of the clouds is not in the shadow. You've also agreed to that. Conclusion by modus tollens. The sun is either not above the clouds or the Earth is not flat. Which one do you prefer?
It depends. It depends at the night or at the daytime.
So which one is it? Is the sun not above the clouds? Is the sun below the clouds, or is the Earth not flat?
The Earth is flat.
Okay, so then it must be that the sun is not above the clouds.
I'm answering you. You don't want to hear. You don't want to hear my answer.
So which one is it? You have two options. Either the Earth is not flat, or the sun is not above the clouds.
I'm answering you. The Earth is flat, and the sun above the cloud.
Okay, so then which of these two premises do you reject?
I don't care about what you written.
Because the conclusion can't be false if both premises are true.
Maybe third. Maybe third premises.
There is no third premise. There's only two premises.
Why? I don't want to put these two premises.
I'm sorry. This is a rule of inference called modus tollens.
Higher than the clouds.
So we agree, if the sun is above the clouds and the Earth is flat, then the bottom of the clouds are in the shadow. You agreed to that. Do you no longer want to agree to that?
Shadow, yeah.
Okay, so if the sun is above the clouds and the Earth is flat, then the bottom of the clouds should be in the shadow. But then we looked at the picture.
Yeah.
Right. We looked at the picture.
Lighting from down.
We looked at this picture, and we see that the bottom of this cloud is not in the shadow.
Yeah,
right?
the side which you see
Well,
in the
this is the
sun,
bottom.
reflecting that sun.
This is the bottom of the cloud,
Reflecting
right?
that sun. Yeah, of course.
Okay,
Of
so the
course.
bottom.
No,
So
the
now we
real
have an
bottom is the
example.
black one.
So you've already agreed to the first premise, right? You agreed
I
that
don't know
the
where you achieve from the shadow of the sun. On the
right.
clouds,
We achieve
the
a
shape
complete
of the
destruction of
earth.
your worldview. You agreed to the first premise that if the sun is above the cloud and the earth is flat, then the bottom of the clouds should be in shadow. And then you also agreed that the bottom of the cloud in the photo I just showed you is not in the shadow, which means that either the sun is not above the clouds or the earth is not flat. So if you want to reject the conclusion, if you think that both the sun is above the clouds and the earth is flat, then you have to reject one of the premises. But you've already accepted both premises, which means that you're just believing a contradiction at this point.
No, not in that way. Well, why you think the sky at night black?
What does
and
that
the
have to
day
do with the two,
white?
with the premise conclusion here, the syllogism?
What's the clouds have to do with the shape of Earth?
Well, it tells us where the sun is
I'm
relative
asking
to
you.
them. So it does,
I'm
it
telling
does
you, the
inform on
sun
the shape of the earth, yeah.
Okay,
In fact,
the sun-
it follows
the sun have
deductively
nothing to
from
do-
these premises.
You never
It follows
listen.
deductively from these
There is
premises
no sun at the
that...
night.
I'm sorry?
There is no sun at the night. Is that correct? There is no sun at the
We
night.
have a winner, y'all. There is no sun at night. Yeah, you're right.
Is that correct? When there is
The
no
sun
sun
is
at the
sun
night,
is down at
why
night.
is the
Yeah.
sky? Okay. Why the sky is black? It's have about thousand and thousand of another stars. Why?
Because
It's
they're
not,
far away.
light. What's the far away is?
The stars.
It's
The
nearer
stars
to
are
the
far away.
sky. It means that the sun is closer to what? To the sky? To make it light.
Yes, the sun is closer
And
to
when it's
Earth
going
than the
darker.
stars are.
Perfect. It means the star is closer to the sky more than the earth. It means the sky at night supposed
The stars
to be
are closer to the sky.
light.
Bro, the sky isn't a place.
It means the sun can light what? At
The sun
day
is closer to the
make
Earth
the light.
than the stars are.
Yeah, and
Just to
you
be
can
clear,
see the
just to be
sky
clear,
at the
we've
daytime.
already established that the sun is either below
you
the
see the
clouds
sky
or
at the
the earth is
daytime?
or the earth is not flat.
Okay. I'm asking you, what's the color of the sky in the daytime?
Why are we pivoting away from the
Simple
argument
question.
that destroyed your worldview?
I'm asking you. I wanted to check your eyesight. What's the color of the sky in the daytime?
Why are we pivoting away from the argument that destroyed your worldview?
I am checking your eyesight, man. What's the color of the sky?
What does
in
that
the
have to do with the
daytime?
argument here?
Is the answer is difficult, or you don't know?
No, I'm just not letting you pivot.
You don't know the answer.
No, I'm not letting you
It's
pivot.
mean you need to check your eye. It's
So,
mean something
okay,
wrong with your eye.
so just for everybody watching, and I think that we can probably end it here. He's accepted premise 1 and premise 2, but he rejects
I
the
didn't
conclusion.
accept anything.
Yeah, you did. You accepted
No.
both of these. You agreed with me on both of them.
I'm telling you, Earth is flat because
I know, because you don't
from Earth
understand. You don't
is
understand
level.
logic because apparently you can't follow modus tollens. Thanks for being here, Muhammad. That was crazy. You know, I should start using that that syllogism more frequently. It's actually like just killer. I'm just gonna copy and paste that in. Oops, copy and paste that into the debate notes because that's just like a killer syllogism. All right, let's read some super chats and we'll move on to our next guest. What am I looking for? What am I looking for? So from Master Miner with the $2, is it possible to measure curvature in a glass? Not the curvature of water, no, it's too small. From the Last Judge with the 10 pounds, thank you so much. Hi Blitz, great work. As always, great work. Have you heard of Newcomb's paradox? And if so, where do you come down on it? I've heard of it, but I don't remember what it was. Let me Google it really quick. Oh, I've heard of it. I don't have opinions on it. It is definitely weird. Also, I bring the word of the day. Widdershins, in direct contrary to the usual... What? I don't know what that means, but thank you so much, The Last Judge. I appreciate you. From Cody with the $10, the sun is a deadly laser. It is not, but I get the reference. From Tainted Search with the $2, he thinks our sun lights the stars. Yeah, that was confused. From Very Good Wizard with the $10, do you think a sun simulator would help sun miracle believers realize anything? Seems sudden perturbation / rotation disturbances would have interesting physical and meteorological consequences. Oh, they don't think that the sun is like an object. Right, they think that it's magic. From Helium Biscuits, are you dropping a coin sometimes? No. Oh, from Dr. Fudge, Widdershins may be a Discworld reference. Yeah, it probably is. I never read the Discworld books, so I think I read 1 or 2, but I haven't read all of them. All right, let us bring up the next guest. Let's talk to Temes. Temes, how's it going?
I'm good. How's it going?
I'm doing all right. Temes, how should I say your name? Is it Times? Is it Temes? Or?
I don't even know. Whatever, Temes. But all right.
Okay.
So the thing is, hear me out. I have arguments for God and flat. I believe the Earth is round, but could we do a religion argument? Because flat Earth is boring.
Not today.
No.
Thanks for being here. Let's talk to Dizon. Oh, didn't I talk to Dizon recently? Dizon, how's it going?
Yeah.
We spoke recently, right?
Yeah, we were on the one with the other two.
Oh, that's right. That's right. Do you think that the Earth is flat?
I got proof. Here's the proof for the local sun.
Okay. Yeah. What's the proof?
Here's the local sun. Look, it's where it goes in the museum at night.
What?
In my picture here I took in the museum.
I have no idea
This
what
is
you're
the
referring to.
local sun. In my
oh, that's the actual
icon.
sun. Okay. Thanks for being here.
Yeah,
Dizon.
that's the look.
Bro's just trolling. Grimlow, how's it going?
Hey, I'm all right. I'm just on my lunch break, so I don't have very long. So,
Okay.
But I've just been watching you live.
Grimlow, what shape do you think the Earth is?
So I think it's a sphere, but you can't think of it as a solid ball sphere. You got to think of it as kind of edgy, but also the sun is extremely massive. I think it's like 2,000
So
of
Grimlow,
our Earths would only
Grimlow, if you
fit
think the
across
Earth is a
face of it.
sphere, then
Yes.
we don't have much to talk about. Let's talk to Lowell. Lowell, how's it going?
It's going good.
Glad to hear it. Lowell, what shape do you think the Earth is?
It's flat.
Okay, why do you think so?
I've been doing research on this. Do you want my premise conclusion?
Sure, if you have one.
Okay, so premise 1 would be direct sensory experience shows a flat surface.
Direct sensory experience?
Yeah.
Okay.
Shows a flatter surface.
Oh, free. Why do you keep using different accounts?
Who, me?
Yeah. We had this exact argument like a week and a half ago.
Who do you think I am?
We had this exact argument like a week and a half ago.
No, that's not my promise. That's not me. I don't know who that
I
is.
promise it's not you. Yeah, I'm sure.
It's really not me, bro. I don't know
Really?
what the hell you're talking about. Yes.
Okay. All right.
Did you say free?
Yeah. Direct sensory experience is what?
It shows a flat surface.
Hold on, let me pull up the premises in the browsers and all this. Direct sensory experience shows a flat surface. Okay, what's premise 2?
Water seeks its level.
Okay.
Premise 3, the Earth is said to rotate about 1,000 miles per hour at the equator and orbit the sun around 67,000 miles per hour. Humans do not feel this motion.
The Earth is said to rotate at 1,000 miles per hour, right?
Yes.
At the equator and orbit
the
at
sun
66,000. It's like 67,000 miles per hour
Humans do
around
not
the
feel this
sun.
motion.
Sun, but humans cannot feel this motion. Okay.
Premise 4 would be horizon always rises to eye level.
Okay.
Premise 5 would be long distance visibility.
That's not a premise, but okay.
What would you say?
It's not a premise. This isn't a proposition, right?
What, long distance? I guess so. Maybe I just messed up there, I guess, but I don't know.
Okay, what's your
I thought that would be a
conclusion?
premise. Premise 6 would be suspicion of institutional authority.
Are you just listing pieces of, you know that this isn't a syllogism, right?
What do you mean?
What you're not offering a syllogism.
Do you want my inference rules?
Yeah.
Well, I was gonna give you these first, and then I thought you was gonna ask for those after.
Well, so none of these are related to one another, right? So there's going to be no inference rule between them.
So P1 would be inductive reasoning.
P1, so there isn't an inference rule that tells you about a given premise. Do you know what a inference rule is?
Yes.
Okay, so what inference rule will your syllogism end up following? Modus tollens? What is it going to be?
Epistemic skepticism. It's combined. It's not just
That's
one.
that's not an inference rule.
It's not just one inference rule.
Which inference rules will it use?
Well, yeah. Well, I'm trying to tell you that, but you're trying to say that there's only one.
No. You can have multiple inference rules in a given argument. A syllogism can be constructed from multiple inference rules. Which inference rules are you going to use?
So yeah, the first one would be inductive reasoning, empirical observation.
Okay, so neither inductive reasoning nor empirical observation are inference rules.
What do you mean?
Those aren't inference rules. Inference rules are things like modus ponens, modus tollens, hypothetical syllogism. There's a whole list of them that you can find.
Yeah.
Inductive reasoning isn't one of them.
What about inference to best explanation?
That's not an inference rule either.
Really?
Yeah, really.
All right.
That's called abduction, not deduction. Inference rules get you to deduction. So why don't I give you an example of a syllogism that might help you a little bit?
Yeah, I know what modus. I know what those.
Do you know what modus tollens is?
Yes.
Okay, can you tell me what modus tollens is?
Modus tollens? Oh,
Yeah.
I thought you were saying modus ponens.
No, can you tell me what modus tollens is?
I don't really use modus tollens.
Okay, so here's a syllogism that uses modus tollens. So we have premise 1. If the sun is above the clouds and the earth is flat, then the bottom of the clouds should be in shadow, right?
Mm-hmm.
Premise 2, the bottom of the clouds is not in shadow. I don't know why I need the in there. Is not in shadow. Conclusion, the sun is either not below the clouds or the earth is not flat. This is modus tollens. So we have if the sun is above the clouds and the earth is flat, then the bottom of the clouds should be in the shadow. The bottom of the clouds is not in the shadow. Therefore, it is not true. It is not true that the sun is above the clouds and the earth is flat, which we can then use De Morgan's laws to reveal that it is either the case that the sun is not above the clouds or that the earth is not flat. So which premise do you reject?
So it's not okay. So you're saying if the sun is above the clouds and the earth is flat, then the bottom of the cloud should be shadow?
Sorry, I'm missing a word. Should be in shadow.
Okay, in shadow.
Mm-hmm.
So yeah, so if the earth is flat, the sun should always be above it, right? Is that what you're trying to say?
Well, if the sun is above the clouds, meaning it's like higher in the sky than the clouds are, i.e. it's like at a higher altitude, and the earth is flat, then the bottom of the clouds should always be in shadow.
Yeah, that's what I'm trying to say. Sorry.
Do we agree on that?
That if agree on what? If the earth is flat, then
If the earth is flat and the sun is higher in altitude than the clouds, then the bottom of the clouds should always be in the shadow of the top of the clouds. The top of the clouds will block the light from the bottom of the clouds. The bottom of the clouds will be dark, and the top of the clouds will be lit.
Can you show me that picture one more time?
Yeah.
So what are you trying to say? That the sun never goes?
What I'm asking is, do you agree with the first premise?
Well, I'm trying to understand it.
Which part do you not understand?
Are you trying to say that since the earth is flat, that the sun should always be above it?
I'm saying if the earth is flat and the sun is above it, then the bottom of the clouds should be in shadow. That's what the first premise says.
Oh, if the sun
If it's
is above
true that the sun is above the clouds, higher in altitude, and it's also true that the earth is flat, then the bottom of the clouds should be in the shadow of the top of the clouds.
Let me see.
But this is irrelevant for the first premise.
Yeah, so
do you agree that the first premise is true?
So the sun being on the bottom of the clouds. What does that mean?
You're not, look, I'm asking you about the first premise, right? The first premise is not an evidential premise. The first premise is a, we're trying to get out like a understanding of what what the geometry of your system is. So the question is do you think that the first premise is true?
If the sun is above the clouds and the earth is flat, then the bottom of the clouds. I'm just confused. Are you saying that the sun always has to be above earth?
I'm not saying anything. I'm saying, look, do you think that it's the case that if the sun is above the clouds and if the earth is flat, then the bottom of the clouds should be in the shadow?
If the sun is above the clouds and the earth is flat.
Right.
So it's if.
Yes, this is called a what's it? There's
Well,
a word.
I need to
not a
understand.
hypothesis. This is it's an if-then statement, right? It's if this is true, then that follows. Do you think that if the thing is true, then it follows? It's conditional. Thank you. That's what it's called.
Okay.
If it's the case that the sun is above the clouds, and it's also it's a hypothetical. Thank you.
Well, it would just be above earth, right? At that point.
I'm asking if it's higher in altitude than the clouds, right? And the earth is flat, should it then follow that the bottom of the clouds should be in the shadow?
Yeah, I understand what you're trying to say.
I'm asking, do you think that the first premise is true?
I understand what you're trying to say. I'm just trying to understand that.
So do you think that the first premise is true?
Can the sun not move? Does the earth not move?
I don't know why you can't answer this question. Do you think that the first premise is true or not?
Oh yeah, well I mean yeah, if the earth was flat then that would actually okay.
Okay, if the earth was flat and the sun is above the clouds, right?
Yeah, it would have to always be above the clouds.
Yeah, and if the earth was flat, then the top of the clouds would be lit up, the bottom of the clouds would be dark, right?
Well, technically speaking here, if we're going in circles around the sun, then that would just mean that...
Why are you bringing up the motion of the earth? I'm asking you about if the earth is flat and the sun is above the clouds, what follows? Does it follow that the top of the clouds should be bright and the dark?
I actually saw some shadows on those bottoms of the clouds.
I'm gonna blow myself up or something. Like I don't know what part you're struggling with.
No, because I actually saw some shadows on the bottom of those clouds.
Hold on. I guess I have to draw you something, a new picture.
Even in the other picture you showed to the first guy.
Okay, I'm drawing you a new picture.
You're gonna draw it like?
Yeah, I'm literally drawing you a picture.
Oh my god.
Because apparently you don't understand.
Oh my god.
See? Okay. Sun is above the clouds, earth is flat, right?
Yeah.
So if the sun is above the clouds, then the sun rays go in all directions, right? And they stop when they hit something, right? So the parts
Can they go through the clouds?
Maybe a little bit. So maybe they like pass through the cloud a little bit.
Like maybe like a little reflection, maybe.
So, but importantly, the top of the cloud will be lit up, right? Because the sun rays can get directly to it. The bottom of the cloud will not be lit up.
So like let's say that sun goes out of view in the horizon.
Wait, hold on. Why are we changing things? Is it the case that if the sun is above the cloud, that the top will be lit up and the bottom will not be lit up?
Well, that's what I'm trying to ask you. Do you think that the sun can't go any lower than that? Do you think it's always stuck in that same position?
Well, if the sun was lower than the cloud, then sure,
Well,
the bottom could be lit up.
Yeah.
But if the sun never gets lower than the cloud, then it'll always be the top of the cloud that's lit up, not the bottom.
Wait. So this is like sunrise doesn't exist?
I'm not talking about sunrise. I'm just talking about where the sun is relative to the cloud.
Yeah.
Okay. You understand?
I understand, yeah.
So we
I
agree
know
on
that.
premise one?
Well, I think that the sun does go under the cloud.
Oh, okay, so you think that there are times of day when the sun is lower in altitude
Not
than the clouds?
lower than the cloud.
Oh, but you just said that there are parts where it goes lower than the cloud.
Well, yeah, maybe.
Okay, so you think that there are times of the day when like the clouds are higher than the sun?
Not higher than it, but like from our point of view, yeah.
Well, this question is about whether or not the sun is higher or lower than the sun. Sorry, whether the clouds are higher or whether the sun is higher or lower than the clouds.
Yes, I understand.
So like, so in order for the bottom of the clouds to be the bright part and the top of the clouds to be the dark part, you would need the sun to be at a lower altitude than the clouds.
Yes, but the sun is so far away that its sunbeams can
Sunbeams can
do
what?
that, right?
Can do what?
Go, put light under clouds.
No, if the sun is always above it, then the light won't go under it. Going under it would mean going down and then back up, right?
Well, yeah, that would mean like, well, are you saying like the sun does not move?
No, not saying that. I'm just asking you if the sun is higher than the cloud, regardless of how far away it is, like laterally. The sun is higher than the cloud. Do you agree, and the earth is flat, of course, do you agree that it's the top of the cloud that would be illuminated and not the bottom of the cloud?
All right, let me give you like an example. Let's say I have like a flat piece of paper, right? And I get a lamp, and I go really far away. Or no, a flashlight. Get a flashlight, I go really far away, and I point it at the middle of that paper. But I'm higher. It's higher.
The bottom of the paper won't be illuminated.
But the lights itself go in every direction.
Yeah, but it doesn't go down and then back up. That's what would be required in order for it.
The sun doesn't go down and up, but the lights do.
Look, so we'll go back to the picture because apparently you're struggling to visualize this, but that's fine. Go back to the picture. Here's the picture. Right? If you wanted what you say to be true, the light would have to go like this and then bend up. Is that what you think's happening here?
No, what I'm trying to say that is happening is that in this picture, the sun is just in that exact spot, which is making it look this way, you know?
Where could you put the sun without putting it lower than the cloud? That would make the bottom of the cloud have light on it and the top of the cloud not have light on it.
How about, let's say this, make the cloud smaller.
Okay. I don't know how that's going to help you, but we can make the cloud smaller. Okay, the cloud is smaller now. Now we just got to continue our lines.
So yeah, we could just agree that that one line doesn't, you know, it would just be actual all light in that area.
Yeah, I'm just drawing representative rays. We can draw more if you want.
Yeah, I understand.
Still, the bottom of the cloud is not illuminated. The top of the cloud is.
Well, no. All those lines would just represent light. It wouldn't just be a line, you know?
That's light moves in a line. The bottom is still dark in this case.
All right, thicken your light.
Light isn't thick. What? This has got to be a troll. You're trolling, right?
No. Listen, because look.
Hold on, you're trolling. You got to be trolling.
It's not going to just be in a direct line like that. Look, you're also missing a bottom. There's a
we can have a piece that goes like this direction, like just like skims it, right? But then the bottom of the cloud over here is still dark.
Well, yeah, we got that light right there on the bottom right there.
That light doesn't make the cloud appear. Sorry, you can't see what I'm pointing to. The light down here doesn't make the cloud appear lit.
Yeah, so light reflects and stuff like that, right?
So like are you telling me that this is reflecting off of the water?
No, that's not what I'm trying to say. I'm trying to say that, you know, this light isn't in just like, you know, one line, right? But
That's
like if
why
I get a
flashlight,
if I get a flashlight and I point it to there will be lines going through my fingers, right?
I have no idea what you mean. There will be lines going through your fingers?
Like light lines.
Light lines?
Yeah.
What?
Like light.
Bro's got to be trolling. He's got to be, right? That's got to be a troll. Right? 100% got to be a troll. I mean, I'm still gonna put him on YouTube as if he's not, but like, because it's good content when people are dumb. But like, that's got to be a troll. From Garain with the $5, a fluid without surface tension would have 0.125 nanometers of curvature in a 4 centimeter glass. Yep, that sounds about right. From the last judge with the £10. Thank you again. Sorry about the Widdershins confusion. I didn't realize I'd run out of words. Widdershins is defined as in a left-handed contrary or clockwise direction. Another fun word is absquatulate. That is a fun word. From Dexter with the $5, Dr. B. Okay, caller, we're going to paint you a picture. No, stop huffing the paint. Dr. B, keep being awesome. I hope you get fully permanently cured. I appreciate that. All right, let us bring up our next guest. Let's talk to this person with a whole bunch of letters and numbers in their names. We'll call him 128. 128. How's it going?
Hey, what's up?
What shape do you think the Earth is?
It's definitely flat.
All right, why do you think so?
Because we can observe it, and also I wanted to talk about that last premise. Are you able to pull it up?
Yeah, I can pull up the argument for you if you want.
Yeah.
Yeah, here you go.
Okay, yeah, there we go. I'm not sure if the other guy was trolling or not, but premise 1 can be disproved just by light reflecting.
Okay, so you think that the illumination from the bottom... Yeah, okay, so what you're saying is, look, it could be that the bottom of the clouds are not in shadow, and the sun is above the clouds and the Earth is flat, because the light is reflecting. What's it reflecting off of?
It could reflect off of leaves, water.
Okay, so would you say that the reflection is going... Would you say that the reflection is going to be brighter or darker than the direct sunlight?
That would be relative to the distance.
Well, the reflection will always travel further than the direct sunlight, right?
Right, but if the sun is further, then it's not going to be as bright.
But look, I'm making a comparison here.
Okay.
If you have two different things, one is if you have two different, say, light sources, one is a direct light source from whatever is producing the light, and the other is an indirect light source via reflection.
Right.
And the light source that is indirect via reflection travels further. Would the reflected light or the direct light be brighter?
The reflective light would be brighter.
Why would the reflected light be brighter if it travels further?
If we're assuming
and it's a
that
reflection.
it's traveling further, then it would be brighter.
Why would traveling further make it brighter?
Because
things get darker as they get farther away, right?
What?
Things are darker the farther away they get, right?
Not always.
Can you give me an example of the contrary?
If you're in a mirror house and someone turns on a light, it's going to be bright everywhere.
The reflections that travel further are going to be dimmer, though.
It's still going to be bright. I guess
we're making a comparative statement, not an absolute statement, a comparative statement. Surely you agree that the ones that bounce more times are going to be dimmer than the ones that only bounce once.
They're going to lose energy, yes.
Okay, so then the reflected light should be less bright than the direct light.
Okay, we'll go with that.
So then we can change this premise and say, then the bottom of the clouds should be darker than the top of the clouds. That should stand up to your for your criticism of the first premise. And then we say the bottom of the clouds is not darker than the top of the clouds. Okay. Do you have an objection to either premise?
That would depend on the sun's position, because the sun rotates around us. So depending on where the sun is would depend on whether or not the bottom of the cloud is not darker than the top of the cloud.
Well, you just agreed that if the bottom of the cloud is being illuminated by a reflection, and reflections tend to be less bright than the direct light source, then it must follow that the bottom of the clouds should be darker than the top of the cloud because they're getting less light.
Right, but if the sun is under the cloud, then the bottom of the cloud would be lighter than the top of the cloud.
I agree. That's why this says if the sun is above the clouds, right?
Oh, I'm sorry.
The first premise is if the sun is above the clouds and the Earth is flat, then the bottom of the clouds should be darker than the top of the clouds. We agree?
Yeah.
Okay, so we agree on the first premise. Do we agree that at certain times of day or in certain scenarios, the bottom of the clouds is not darker than the top of the clouds?
Yes, correct.
Okay, so then it follows that it is not true that the sun is above the clouds and the earth is flat.
Why would that not be true if the earth, if
Because
the sun
both, you
rotates
accepted
around
both premises. If you accept both premises, then the conclusion follows.
It is not true that it's a little. I'm not sure if it's cut out or is that the next.
Oh, I'm sorry. I'm sorry. I can. Maybe that's better.
Oh, okay. But I don't understand. If the sun rotates around the earth, then how would it be true?
Look.
Or how
Okay.
would it
Hold on.
not be true?
Hold on. I gotta do something really quick.
Okay.
I'm just. Well, I'll show you what I'm doing. I'm just making it a little bit more precise. Then this bottom of the clouds should always be darker than the top of the clouds. The bottom of the clouds is not always darker than the top of the clouds. Therefore, it is not true that the sun is above the clouds and the earth is flat. Or we can summarize this another way. We could say that this is equivalent to it. Either the sun is not above the clouds, or the earth is not flat. These two things are the same. If it's not true that the sun is above the clouds and the earth is flat, then one of them must be false. So either the sun is not above the clouds or the earth is not flat. So just to kind of back up a little bit, if I say that if it's what's a good example? If A, then B, not B, do you think that it therefore follows that A is not true? Let's say.
But both A and B could be true though if the sun rotates around the earth.
But so do you agree that if it's true that A implies B, and it's also true that B is not true, i.e. B is false, we can say, does it therefore follow that A is false?
Well, you're going under the premise that the sun is not rotating.
Wait, can you just answer this question? This is we kind of walked back a little bit.
Yeah, I understand what you're saying, and in this premise, with the with
So
everything you're saying,
so
yes, C would be correct.
Right. So for any choice of A and any choice of B, as long as it follows this form,
right,
then if A, then B, B is false, therefore A is false. This is like whatever I put in A, I could put in A.
I understand what you're saying. Yeah.
Like it's raining. Then I could say that it's raining is false, and I could put B here as I get wet, and then I say I get wet is false. Like we agree that this is a valid form of argumentation, right?
Okay, right.
Okay, so I can put anything in these as long as it follows this form. So if we scroll up here, we agree that this is in that form, right? If A, then, we can put this in parentheses, then B, and then we have the bottom of the clouds should always be darker than the top of the clouds, is false. That's the same as saying the bottom of the clouds is not always darker than the top of the clouds.
Mm-hmm.
And therefore it follows that this statement is false. The sun is above the clouds and the earth is flat is false, which is equivalent to saying that either the sun is not above the clouds or the earth is not flat. So this is saying if you accept premise 1 and premise 2, then it follows that either the sun is at some time of day, the sun must be lower than the clouds, like its altitude has to be lower, or the earth is not flat.
I don't understand how this is assuming that the sun does not rotate around the earth.
Whether or not the sun rotates around the earth is kind of irrelevant. The question is its altitude, right? Is there ever a time when the sun is lower than the clouds?
Yes,
in
and
altitude?
there's also a time when the sun is above the clouds.
Right, okay, so when is the sun lower in altitude than the clouds?
Where usually because of like time zones and stuff like that, you guys.
I don't mean like where it appears. I just mean like when its altitude is lower. You know, like you have the altitude of a plane. Like the clouds are like 5 or 6 miles up.
When the sun sets.
When is the cloud lower than 5 or 6 miles up?
I'm sorry?
When is the sun lower than 5 or 6 miles up?
Whenever it's setting.
Okay, so like at 7 p.m. for me. The 7 p.m. is around sunset right now. Maybe 6:30. So you're saying that like at 6:30 Pacific time, you're saying that the sun is lower than 5 miles.
Right. It's doing its second rotational phase.
So like the sun is lower than 5 miles. So that means so you're telling me that like at 6:30 p.m. it's possible for a plane to go run into the sun Because planes
Well,
fly
they'd
at
have
like
to-
6 to 7 miles.
They'd have to go past the edge.
So when the sun is lower than 5 miles for me, it's like
No,
noon
no.
for somebody.
I think
it's like
well, you
noon
have
for
to
somebody
realize-
in China.
you have to realize like its scale. You know, the sun is so large.
I'm just asking about the altitude, right? The altitude of the
Okay.
sun.
But it would be relative, right?
Altitude isn't relative.
Well, it is because the sun wouldn't
Altitude
be
is just how
5
high it is
miles-
above the earth.
But the sun wouldn't actually be 5 miles below the clouds. It would just appear 5 miles.
I'm not
below
asking
the
how.
clouds.
Look, I'm just asking how high is the earth above the earth? How high is the sun in miles or meters or whatever? How high is the sun above the earth?
I don't know that exact number, but I do know we've never reached it.
Is it ever below the height of the clouds?
From your point
I'm
of view,
not asking
it
about
is.
perspective. I'm asking about altitude.
Sure, we can say yes.
Okay, so it is your view that so clouds, you know, they're usually 5 or 6 miles up, as long as it's like, you know, mist can be on the ground, but regular clouds 5 to 6 miles up. So, and so you're saying that it's possible for the sun to be less than 5 to 6 miles up. So maybe it's 4 miles up.
Okay, from your point of view.
This is not a perspective thing. This is just how many miles it is above the ground.
Oh, okay.
Right. So it's from everybody's point of view. Everybody would agree that it's 4 miles up.
At that point in time, yeah.
Right. So at say 6:30 p.m. my time. 6:30 p.m. everybody would agree that the sun is 4 miles above the earth, say?
Yeah.
Okay. But that means that a plane could fly into it. Because
But
planes
the
fly
sun-
higher than 4 miles.
Right, but the sun isn't. This is what I was saying. The distance from the sun and the fact that it's past the edge wouldn't allow you to fly into it. Because of, let's just say,
Wait, but it's only 4 miles up. Why couldn't we fly into it?
Because let's just say that let's just say everything is water level, right? Everything is just the same flat plane. If the sun goes below the 4 miles, 5 miles, 6 miles, whatever you want to call it, you still wouldn't be able to reach it. If the sun was close enough, we would all die and burn.
Wait a minute, but I'm a little bit confused. So if at 6:30, let's say it's at 6 o'clock for me, just to make the numbers easy. I'm gonna go look up some time zones really quick, just so that I don't lie to people. But so I'm currently in -8, so I would have to go to +10. So if it's 6 o'clock for me, where the sun is only 4 miles above the earth, right? It's lower than the clouds. It's noon for people in Sydney, Australia. So for them, it should be really high in the sky. So is it still only 4 miles above the earth for them?
Yeah.
So why is it that the sun, why can't a plane in Sydney just crash into the sun if it's only 4 miles up?
The sun has 4 different rotational phases.
That seems like it doesn't ask my question or answer my question.
Okay, so when you see the sun set, that's actually you seeing the sun go below the edge. And when someone in Australia sees the sun,
So-
that's them seeing.
Wait, hold on. You think that there's an edge? That the sun goes below?
Yeah.
Okay. Just to be clear, you know that sunsets don't happen at the same time for everybody, right?
Right.
Okay. So when the sun sets for me, it's 7 p.m., say, has the sun gone over the edge?
No.
Okay. So then why did the sun set?
It rides the edge. When the sun sets for you, it dips and then rises.
So at the time when the sun is lowest in the sky, that's when it is below the edge, or when does it go below the edge?
When you no longer see the light. is
Okay,
when it's
so
below
at like
the-
midnight for me, the sun is below the edge?
Right.
Okay. But at midnight for me, that's like the middle of the day. That's noon for, I don't know, people in Afghanistan? So like, how can it be below the edge from for me, but directly above them in Afghanistan?
I just explained it with it goes below the edge, it goes into its second rotational phase, and it rises. By the time you don't see it anymore because you're not like close enough to see it.
Where is the sun when it's midnight for me? Where is the sun actually? I don't care about like where it appears to be. Where is the sun actually at midnight for me?
For midnight for you, it would have dipped below the horizon and would continue to rise.
But the horizon is a relative thing. I'm asking, like, where is it actually?
It's gone below the edge.
Okay,
And then
where
it
is the
rises.
edge?
But it doesn't fully go below the edge.
Where
That's
is the
why
edge?
It's still daytime.
Hold on, where is the edge?
Nobody knows. We've never reached it.
How can it be both below the edge and also above the ground?
It doesn't fully submerge below the edge.
Then why'd you say below the edge?
Because it dips below the edge.
How
but
can it be?
does- you
How can it be
still see the
dipping
sun.
below the edge while also be just hanging out in the sky?
Well, I guess I misworded it. It would not fully dip below the edge. You can still see it, and that's why.
How can it be near the edge but also just hanging out in the sky?
It's relative.
How is that
The
relative?
reason
We're just asking about
Australia-
where it is.
It's because of scale. Australia is not. Let's say you live in New York. The position of the sun is not going to look the same in the sky as someone who's in Australia.
Well, I agree with that, but that's because the Earth is a globe and the sun doesn't actually move and the Earth doesn't have an edge.
Well, the Earth also can't be perfectly flat. You know, we have mountains. We have a lot
Obviously.
of different areas.
Look,
Yeah.
look. Maybe I'm just not understanding, but like it seems like if it's midnight for me, that means that something has to be blocking me from preventing me from seeing the sun, right? Something's blocking it.
Okay, I mean, there's a lot of those. Yeah.
Okay, what's blocking it?
I mean, if you're talking about the distance from Australia to New York, it could be anything from the Himalayas. It could be, you know.
Well,
it could be-
I mean, not necessarily. Let's say that I'm in California on the coast, right?
Okay.
If it's say 8 p.m. for me, we can just you know, nighttime, like definitely nighttime. Let's say it's 8 p.m. in winter. Then the coast of Australia, there's a straight line connection between the coast of California and the coast of Australia. There's nothing in between besides water, right?
Mm-hmm.
So it could still be 2 p.m. for them when it's 8 p.m. for me. So how is it that what's blocking my view of the sun at 8 p.m. when I'm in California? But it can be, but there's still a straight line, no obstruction to the coast of Australia.
That's assuming there's no obstruction.
Well, it's just the ocean, right? Like there's nothing in the way. There's no mountains. It's just the ocean.
I mean, there's Hawaii. There's
No,
other
I mean
islands.
the ocean covers most of the space. There is definitely a straight line, like I can assure you that there's a straight line connecting California to Australia.
If we assume that there is nothing blocking the light, then you would be correct. But there are things.
Like what?
There's many islands. We have tens of thousands of islands, probably more.
Look, so there, you know that there are places that you can be in California that will give you a straight line connection to Australia with no islands in between.
I've never observed that.
You know that most of the Pacific Ocean doesn't have any islands in it, right? Like most of the Pacific Ocean is just water. It's not mostly islands.
I've never observed that.
Just go look at a map. Here, I'll draw you one. High resolution map of Pacific Ocean with islands. Oh, actually, maybe this would help. Every single island of the Pacific Ocean mapped. Okay. Open image. I'm just going to copy this image and I'm going to paste it in. Now, come on, paste. There we go. Zoom out. Oh, that was really big. Okay. So, let me just draw a line. Okay, I found one.
Okay.
I will show it to you in a sec once I make that black. There we go. Okay, here we go.
Yeah, and just a heads up, my phone is at 2%.
Of course it is.
Yeah.
I'm completely unsurprised.
Not very responsible with charging my devices.
Right. Okay. So here we have a map. And I just put like, you can choose whatever projection you want. You can always find this because it's not very dense. So here we have Australia, right? This is the, oh wait, sorry, I'm showing you the wrong thing. Wait, here we go.
I should plug it in, huh? All right, hold on.
You plug it in eventually, yeah. So here we have Australia. This is Australia here, right? And here we have a line, straight line that connects Australia, and we can follow this. This is a map of every single island in the Pacific. So I'm following this straight line. It skims by the edge, but doesn't actually touch this island.
Okay.
It continues. It passes between the islands of Hawaii. It continues until we get to California. So there's a complete unobstructed line of sight between between California and Australia. So why can't I see the sun?
You also drew that line on a globe.
I could draw it. You pick whatever you want, whatever projection you want. I will be able to find a line.
Look up a flat Earth projection.
Okay. Just got to go find one that has all the relevant islands and also has, okay, is this a good one? Might be a good one. That's kind of low resolution, but that's a little bit hard to see. Is this a good one? Maybe. Yeah, okay, this is a good one. So this is the one I'm going to use. Right? Flat? No curvature.
That's not the right globe model or the flat Earth model.
I'm sorry. What shape is the Earth?
I was going to say that's the wrong globe model because it looks very similar to a globe model.
Not a globe. This is a flat projection. Look, the point is that islands are small, and in order to obstruct every single line, you would need to cover the entire ocean.
But we just said that the sun could be below the clouds, so it would definitely be possible that the mountains would block it, the islands would block it, the clouds.
No, the mountains wouldn't block it because there are no islands. There will always be a place between, there will always be a place in California and a place in Australia that you could connect with a straight line on whatever model you choose that will be able to avoid every single island.
If we assume that, we can say
no, that's just true. That's just true because the islands are sparse and the islands are small.
I mean, if we assume that there are no islands in between, then yes, that would be true.
Okay, and there are straight line paths that you can take between California and Australia that don't run into any islands.
If you take a plane from Australia to California, you will be going through islands. You
Not
will see
necessarily.
islands. You will see islands.
You might be able to see islands to your left or to your right, but that doesn't mean that they would block a straight line view.
The plane itself would also block the sun.
What?
The plane itself would also help with blocking the sun.
How would the plane be? What? This has got to be a troll.
We just went through premises where we assume that, well, we don't assume, we know that when light reflects, it loses energy. So if the light is going to reflect that many times, by the time it gets to California...
What does the plane have to do with anything?
The plane would reflect some of the light of the sun.
I'm asking why you can't see the sun when you're in California and people in Australia can see it.
I just explained it to you. There's many things blocking, and there's many things.
What's blocking it? We've already established that there are paths between you and Australia that have absolutely nothing blocking it. There's no islands in the way.
All of these are using projections from globe models.
Look, you understand that islands are very, very small, and the Pacific Ocean is very, very big, right?
Okay, let's say there's a mountain.
Do you understand that?
Yes, and let's say that there's
so then
a mountain.
the odds of, like, if you pick a random path connecting Australia to California, like a random straight line, pick any random place on the coast of Australia and any random place in California, the odds of running into an island are minuscule.
But
because the islands are very, very rare and they're very, very small compared to the size of the Pacific Ocean.
But they exist.
Yeah, of course they exist. The odds are low.
which would be a factor in why you cannot see the sunlight.
If they're
in
look, if
California.
they're not directly in line of sight, then they wouldn't obstruct the sun.
But they are. That's
Prove it.
why you can't
Prove
see
it.
it.
Burden of proof is on you. I already showed you an example of it not being the case. I already showed you like a perfect example of a line that you can connect Australia to California with that doesn't hit any of the islands. Burden of proof is on you now to show that there is no possible path, no possible straight line path between Australia and California that will not intersect with some island.
How? Okay, explain to me this. If the sun is over by Australia and there are mountains in Australia,
we're talking about the coast of Australia.
I'm sorry?
We're talking about the Australian coast, the east coast of Australia.
You would still see the sunlight even if it was on the opposite side of Australia, but it would be much.
So if you're on the east coast of Australia and it's 2 p.m. for you, then the sun will be somewhere over the ocean, right? It won't be directly overhead. It'll be further east.
Okay.
So the mountains in Australia don't help you here.
The islands and the clouds and the airplanes definitely would allow you to not.
How
see
would the
sun.
airplanes block the sun?
Do you know how much commercial traffic we have?
How big is a plane compared to the sun?
It's much smaller.
Right. So how is an airplane going to block the sun?
But it's not blocking the sun. It's blocking the light from the sun.
Yeah, that's what it means to block the sun.
Well, there you go.
So you're telling me that a plane can block the sun?
You see it happen when a plane goes over. Let's say you're in San Francisco downtown and a plane goes over the sun. It gets dimmer. Does it not?
Yeah, you know that you can still see the sun though, right?
Well, yeah. But that.
So
but
why
you have
can't
to
why can't I see the sun when I'm in California if it's 8 p.m.?
But you're not taking into fact the scale. You realize if you're in California and the sun is all the way in Australia, it's not going to be as bright as if it was on top of you.
So to be clear, is it your contention that the reason you can't see the sun at 8 p.m. in California, but you can see it from the eastern coast of Australia, your contention is that the planes in the sky collectively are blocking the sun?
Along with many other factors.
What are the other factors?
The mountains.
What mountains? There's ocean between Australia and North America.
Well, in this hyper-specific scenario, that would be true.
Okay. So it's just the planes that are blocking the sun?
Plains, clouds, islands, mountains.
Okay, so to be clear, there are no islands or mountains between
California. Has its own mountains.
Right, but we're on the coast and we're looking west or southwest, really.
Yeah, that's why I said in this very hyper-specific.
Yeah. So if you're and people live on the beach in California, and they can't see the sun at 8 p.m. So you're telling me all of those people are having their vision obstructed by planes
and clouds?
And clouds. What about on clear days?
On Earth, how many clear days do we have where there's no clouds?
Well, no, I mean so look, if they can't see the clouds because it's a clear day for them, or a clear evening, I should say. If it's a clear evening for them, if they can't see the clouds, then how could the clouds be blocking the sun, which they should be able to see if there were no clouds?
But I don't. So you're saying there's no clouds in California, but there's no clouds over the Pacific Ocean?
What I'm saying is that, look, if there were, suppose we're in magical Christmas land and there's no clouds anywhere on Earth at 8 p.m. in California.
Then yes, you would see it.
So that means that you would be able to see the sun, right?
And if there's no planes, no clouds, no nothing.
Right. No planes, no clouds, because we know we've already ruled out the mountains and the islands. If there's no planes and no clouds, then we should be able to see the sun, which means that the sun would be visible in the sky. Which means that if there is going to be a cloud or clouds that block the sun, then the clouds should also be visible in the sky, right? Because they would have to be in between you and the sun. They'd have to be blocking the light.
Right, but we already agreed that as light.
Right. So if it's true, so I'm glad you agree that the clouds would have to be visible in the sky. So from the perspective of California, if it's a clear night where there are no clouds visible in the sky, then that means that it can't be clouds that are blocking the sun, because if the clouds were blocking the sun, then the clouds would be visible.
You would not. Okay, I think we're a little confused here. Yeah, if there were no clouds from if there were no clouds,
it doesn't have. It just has to be from the perspective of someone in California.
You would not be able to see this if there were no clouds only in California and there were still clouds.
If there were no, so look. Sometimes, like, you know what a clear day looks like, right? Where it's just
right, but
it's just the ocean and then the sky above it, right?
And that's relative to your position.
Yeah. So relative to somebody in California, if there are no clouds that are visible,
in California,
then that means that those clouds can't be the things blocking the sun. Because because you've already agreed that if there were no clouds, period, and no planes, then the sun should be visible in the sky.
Right.
And so if it's the case that clouds are blocking the sun, then those clouds would have to also be visible in the sky.
Okay.
So that means if the clouds would be visible in the sky, then that means that it's not a clear day for the Californian.
If you turn on the light and close the door, is the room going to be as bright as when the door was closed?
I don't see what that has to do with anything.
I'm saying the clouds are diffusing the light. There's the amount of light that you're going to see on a cloud in the Pacific Ocean is not as much light as you're going to see on a cloud in Australia.
You should be able to see the cloud, period. You should be able to see the cloud in the sky.
As the distance gets further, it becomes dimmer and dimmer to the point where there is very minimal amount of light.
Oh, okay. So it's your view that you can't see the clouds just because they're barely illuminated.
Right.
And so these clouds are like near Australia.
Right.
And so like the barely illuminated clouds near Australia are blocking the sun.
No. The clouds in Australia would be illuminated, but as you get further and further from the coast, those clouds will get to be dimmer.
But we're back in trouble again, because now it seems like what would be required is that the clouds have to be at the same altitude as the sun in order for the clouds to block the sun, the sun's rays, right?
Not necessarily.
Over that vast distance, right?
Okay. But not necessarily.
Well, over that vast distance, they would. Right? The clouds can be lower than you if the sun is directly above. Sorry, the clouds can be lower than the sun if the sun is above the clouds and the clouds are blocking you from seeing it while looking up. But if the clouds are blocking you from seeing the sun when the sun is really, really far away, then that means that the clouds would have to be at the same level as the sun.
Right.
But the clouds aren't at the same level of the sun. I thought we agreed that the sun is higher than the clouds.
We also agreed that the sun can get below and at the same level as the clouds, and even if they
then you can fly into the sun with an airplane.
But it's not close. Yeah, you can, but it's not close enough. You would have to have a lot of fuel, and no one's ever done it before.
You can fly into the sun with an airplane?
Not with an airplane.
You just said that we could.
If it wasn't an airplane, yeah, you could. With a specially modified aircraft, yeah.
You could fly into the sun.
With a specially modified aircraft.
Because the sun is only like
they've made,
5 or 6 miles up,
experiments.
Right?
I'm pretty sure they tried to launch like a rover.
How high is the sun?
I'm sorry?
How high is the sun?
In the scenario we're talking about?
Yeah.
It could be noon.
Yeah. No, I'm not asking what angle is it at. I'm asking like how high above the ground is it?
From your position, it would probably be
no. This is not a
miles.
perspective thing. I'm just asking like how many feet is it above the ground? It's not a perspective question.
I don't think we could measure that in feet.
How many miles is it above the ground?
It would be millions.
Millions of miles above the ground.
In reality, but
yeah.
No.
That's what I was asking.
Sorry.
Wait.
It would be millions of miles away from us. Above the ground, it would look like it's 4 miles. That's what I was trying to tell you before.
What? Wait, hold on. Okay, look, you realize that like the height of like the altitude of something is not relative to somebody. An airplane flying at 35,000 feet is 35,000 feet in altitude, regardless of who's looking.
Yeah, we can agree on that.
So I'm asking, what is the altitude of the sun?
It is
it's not relative to anything.
If you're standing on a
35,000 feet.
skyscraper, if you're standing on a skyscraper and something is 5 miles above you, it's not going to be 5 miles above someone standing on the ground.
We measure altitude relative to the ground, right? It's how many feet above the ground, how many miles above the ground.
Okay.
So how many miles above the ground is the sun?
It would have to be. I couldn't give you a number on that. There's a number on that. I just don't know what.
Okay, is it less than 1 million miles?
I'd say the distance is 1 million miles, but from us, it looks like it's 5 to 6 miles.
I have no idea what that means. How can the distance be 1 million miles, but for us it's 5 to 6 miles?
Because of altitude.
Are we 1 million miles minus? Are we like 999,995 miles above the ground?
No.
Okay, so what is the altitude of the sun above the ground?
At most, I believe the number is like 10 miles. above
Okay.
the ground.
That's the
But
highest that the sun
it-
ever gets above the
But
ground.
that's how we. That's exact. But it's still far away from us. Do you understand?
Yeah, sure. Except so when it's like directly at noon, when the sun is directly above you, it is at most
From your
10 miles away, right?
And that's from your perspective.
Yeah,
though.
but it's at most 10 miles above you. And it's not anywhere horizontal.
No, the distance is far, but
How is
it
the distance far if
above.
it's directly above you?
But it's not directly above you.
At noon, it
We have
can
an
be.
atmosphere. We have an atmosphere that warps the
When it's
sunlight.
directly above you, there's no refraction because it's coming straight down. There's no refraction there.
I don't understand what you're saying. If it was
The atmosphere
directly above you, it
doesn't.
would still
So the distortion that the atmosphere causes only causes distortion when light is coming in at an angle to you relative to the vertical. And the reason for that is because the atmosphere is in horizontal layers. So when light is coming down straight through those horizontal layers, there's no distortion.
Okay.
So when the
I
sun is
don't
directly
understand.
above you, like
There-
it
there
is
is
twice a year in
distortion.
Hawaii.
There is distortion. That's why you can see the sun as being above you in Australia.
Well, no, I mean like twice a year in Hawaii, the sun is directly above you, and because of the layering, the horizontal layering of the atmosphere, there is no distortion. That's provable using standard optics.
Okay,
So-
I have not observed that, but we can assume that.
It's called Lahaina noon. It's pretty well documented. It's a particular thing that happens in Hawaii. In fact, it happens anywhere if you're within the tropics. You get it twice a year if you're within the tropics, between the Tropic of Cancer and the Tropic of Capricorn. So Lahaina noon is a thing. And so for those people, the sun is 10 miles away from them. Right?
No, it's not. If
But
we
if it's only 10
assume that
miles
there
up.
is no, yes. If we assume that there is no light refraction, then yes, it would be
Well, you
directly
don't have to
above them.
assume that. That's just like provably the case.
But that would kill them.
Yeah, you're right. So it sounds like the sun isn't 10 miles up.
That's why I was saying from our perspective, it looks from our, let's just go back to how I was saying everything is one flat level. It would be 10 miles above us, but it wouldn't actually be 10 miles above us because there's a distance. If the sun was 10 miles above Hawaii, the earth would be gone.
I mean, I agree. But then why'd you say that it was 10 miles above the earth?
Because it's from your perspective. If you measure it above the flat plane level, it's going to be 10 miles.
Okay.
But
if it was 10 miles above the earth would be gone.
Because it doesn't go above the earth. It has rotational phases.
So to be clear, during Lahaina noon, when it's directly above you, it's not directly above you?
It's not.
Oh, where is it?
I've never observed this Lahaina noon. I couldn't tell you.
I can show you pictures. It's actually really incredible.
That does sound really incredible, and it probably has something to do with the atmosphere.
Funnily enough, here's a picture of a level at Lahaina noon. See that? Isn't that weird?
Oh, yeah.
There's no shadow.
Yeah, that's directly above.
Yeah. So when this photo was taken, is the sun 10 miles above you?
It's not. It just appears to be.
Then why isn't there a shadow?
Because of the light refraction from the atmosphere.
But light doesn't refract when it's entering vertically.
I know we have plenty of satellites too, so I guarantee you.
Light doesn't refract when it's coming at you vertically.
Because it's not coming at them vertically though.
If it wasn't coming at them vertically, then there would be a shadow.
You can refract light to make it perfectly vertical.
No, you can't. Snell's law forbids it.
You can.
Snell's law forbids it.
It's been observable though.
Prove it.
Hello?
Hello.
Oh, okay. Well, whenever I swipe up to go to my browser, you can't hear me. It doesn't interact. I'll have to find the experiment later.
Yeah, you will, because it turns out that this is like impossible according to Snell's law, because you would have 0 on one hand on the right hand side of the equation, and you have something that's not 0 on the left hand side of the equation. So this is like actually impossible. This is you're suggesting that the laws of physics have been violated.
Yeah, I mean, I know. I'm not sure how you guys feel about I'm not trying to promote or anything, but there is a I'm not going to say the name, but there is a flat Earth Discord that has a lot of these proofs and experiments that you can go ahead and take a look at.
They will never be able to show how you can get light refracting so that it ends up pointing straight down vertical. They will never find that.
They have done it.
I challenge you to find it.
I wouldn't be able to while we're on this call.
Okay, well then come back next time with the proof, okay?
Yep. All right. It was a good
All
talk.
right. Take care. Why can't I? Where's the thing? He will never come back with the proof. And just so I can clarify things for everybody, let me show you Snell's law. Just that way then we can be super, super clear. So this is Snell's law. It's actually like a pretty good model for our atmosphere. Our atmosphere is obviously not like straight layers, but like it's very, very close to it. So the point is, and the point that I was just making, is that if you wanted one of these angles to be 0, so that the light is coming straight down, you can imagine flipping this upside down and you get the same thing. If you wanted one of these lines to be 0 relative so that it's straight up and down vertical, then that means that you would have the sine of 0 degrees, which is 0. And on the other hand, if the sun is not starting out vertical, if it's coming in at an angle, then that means that the sine of that angle is not 0. And so what you would find is that you have something not 0 must be equal to something that is 0. And that's obviously not true. Hence, from Snell's law, you can show that you can never use refraction to end up with 0 or to straight up and down vertical light beams. It just doesn't work. All right, let us read some super chats and then we'll bring up our next guest. Actually, one sec. Just gotta copy and paste something really quick. Okay, cool. Super chats, that's what I was doing. All right, from the last judge with the £5, hi Blitz, was wondering if there was any way to get an editable copy of your debate notes for personal debate purposes. If not, completely understand. Yes, you can. What you would have to do is you would first need access, and you can get access by becoming a YouTube member or by becoming a Patreon member. It's like $4 or $5 a month, and you can get access that way, and then you can make a copy of the notes for yourself. You can't make an editable copy. You can't edit the main one because otherwise then people could vandalize it. But if you get a copy of the debate notes, if you get access to them, then you can just make a copy of them. That should work. Do TikTok superfans get access? Unfortunately, there's not a way that I can give you a link if you are a TikTok superfan. So I strongly advise that people. I also get a larger percentage of it if you become a member on YouTube or on Patreon. I get all of it on Patreon, and I get like 70% on YouTube rather than I think the 60% I get from TikTok. So I would strongly suggest become a member on YouTube or on Patreon, and I'll get more of it, and then you get all the same perks. From Dr. Fudge with the $2, TimeCube explains this. It does actually. TimeCube would have been the solution that he was asking for. Oh, I'm sorry. I'm so sorry. I muted myself. Yeah. So from Patrick with the 1,000 Hungarian francs. I can't even imagine how hard it is for you. I debated with FLERFS for 2 hours and it is really depressing. They can't understand anything. Absolutely, they can't. They struggle a lot. From Ekapo with the €5. My phone is on 2% equals I need to return some videotapes. It's so funny though. From Enrock with the $2, Plains, Mountains, and Islands MTG mentioned. Oh my god, you're right. Plains, Mountains, Islands, he just needed to mention swamps and forests, and he would have had the whole thing. From Ghost of Xbox with the $10, like and subscribe. Indeed, y'all, make sure to like and subscribe. It helps me. Not francs, I'm sorry, forints, not francs. But I got Hungarian right. Yeah, it's forints. Francs, francs are a French thing. From Dr. Carla with the $10, sending you $1 for every mile the sun is above the earth. Oh, I smell a flat earther here. Somebody asked, can n equals 0 in Snell's law? No. So n can never be less than 1. All right, so that is all the super chats we have for today. Let's, or for now anyway, let's move on to our next. Oh, let me just check some things. Sorry, I just gotta check on some messages. Then we'll bring up our next guest, I promise. But he pinged me and I don't know where. Okay, I don't see it. It's fine. Don't worry about it. It's fine. All right, let's bring up our next guest. Let's talk to Ben Rice. Ben, how's it going?
Good, how are you?
I'm doing A-okay. Ben, what shape do you think the Earth is?
I think it's I think it's a sphere, obviously, you know. I'm not stupid, but I just wanted to join and ask you a question.
Well, unfortunately, it does say opposition only, so I do gotta let you go. But thanks for being here, Ben. Remember, y'all, please respect the live and only join if you're opposition. Nika, how's it going?
Hello. Bro, I want to know, how can a snail invent a love? They are not that smart.
What? All right, let's bring up Zookeeper. Zookeeper, how's it going?
Good, and you?
I'm doing okay. Zookeeper, what shape do you think the Earth is?
Flat.
Okay. Why do you think it's flat?
I'm just gonna go off of your model. Can we go to your drawing that you did, and we're gonna create a center in place for it.
I deleted the drawing. Let me see if I can find it. Okay, yeah, I can undo it enough. Yeah, okay. So you mean the thing with the cloud, that thing?
Yeah. So are we gonna agree that for 6 months, matter of fact, first let me ask you: is there more than one sun in the Earth? Yes or no?
Definitely doesn't look like it.
No, right? So for your sun to be stationary for 6 months, it would be strong enough to illuminate the whole Earth, correct?
I have no idea what that means. I don't know why that would be true.
All right. So
if
would
the
you
sun
agree
is
or
stationary for 6 months, it would be strong enough to illuminate the whole Earth? I don't know what that means.
Okay, so let me rephrase that.
Please.
Are you aware that the sun is in the Antarctic Circle for 6 months?
No, it's not.
No, it's not.
No, it's not.
The North Pole.
No, it's also not in the North Pole for 6 months.
It isn't. You're saying that there isn't a sun in the North Pole for 6 months.
You can see the sun from the North Pole for 6 months, but the sun isn't in the North Pole.
It's in the Antarctic Circle.
No, it's
That's
not.
what I just said. The
No.
sun is in the Antarctic Circle, where you can see it.
The Antarctic Circle is the South Pole, by the way, or it's the Southern Circle. The North one is called the Arctic Circle, and even then, the sun is not in the Arctic Circle for 6 months. The sun is north of the equator, or rather the subsolar point, which is the place where the sun is directly above. The subsolar point is between the equator and the Tropic of Cancer for 6 months. By the way, when you're off the app, I can't hear you.
I was just looking at my notes. That's all. While I was listening. While I was looking, before I say something incorrect. So the direction of the sun goes from left to right, from the Arctic Circle to the north. That's what I'm trying to explain.
The sun goes from left to right from the Arctic Circle?
Yes.
Is that true?
Yes.
That seems plausible.
Yes. This is what I'm explaining to you. I may not be saying it right where you can understand.
I'm just thinking. Yeah, so it would be... Yeah, sure. That's fine.
So for there to be one sun, and for we can understand that at a certain height and distance, clouds are able to block light. Are we going to disagree with that?
Clouds can block light, yeah.
Okay, so because I heard you many times disagree with two prior guests that you had, that clouds cannot create shade, basically.
No, I've been saying over and over again that clouds do create shade. That's the whole point of the argument. That the top of the cloud shades the bottom part of the cloud.
Right, and now that we got a stationary plane for where the sun is, whether you want to disagree or not agree, whether you believe it's a round Earth or a flat Earth, for 6 months the sun is in the Antarctic Circle.
No, it's still never in the Antarctic Circle. No, even on a flat Earth, it's never there.
Okay, this is science.
It's between the Tropic of Cancer and the Tropic of Capricorn. You understand this, right?
The Tropic of Cancer and the Tropic of Capricorn?
Yeah, that's where that is the path of the subsolar point for the sun the entire year. It moves between those two latitudes.
So you're basically saying that science is stating that for 6 months it's not in the Antarctic Circle. Is that what you're saying?
Science doesn't state that.
Okay, now I'm going to pause and I'm going to go back to my notes.
Go back to your notes. Capricorn.
So like I was stating, the sun set once a year in the south of north, the north and
when
the
you
south
minimize
pole.
the app, I can't hear what you're saying, so you cut out.
That's so when you're saying that the sun sets, it sets from the north and south pole.
What?
So you have your distance.
Wait,
where
what? Hold on, when did I say that?
When you're talking about distance in the clouds, and you're talking about how when the sun goes left to right, and we already agreed that the sun goes left to right, and
in the Arctic,
Earth, yes, in the Arctic. So for there to be 24-hour sunlight, the sun has to be stationary, correct?
No.
No?
It literally moves.
I would have to disagree.
Like, from your perspective, it goes around your head. It doesn't just stay in one place. Like it,
right,
it goes
in a
all the way
circle,
around.
correct?
Yeah.
In a circle, right? So
yeah. It's moving around. It's moving like the subsolar point is moving around the Tropic of Cancer or the Tropic of Capricorn, depending on whether you're in the north or the south. And so
from that point, you would be able to see the sun, correct?
Sorry, one more time.
So from that point, you will be able to see the sun, correct?
Yeah, it'll be in different directions at different times of the day.
Okay, so that's our starting point for your drawing. So if we're moving at a distance from that distance, you would see that each cloud would not have visible distance from top to bottom. That's where the light is seen below and above.
I don't follow that. That
How
doesn't
don't
make sense
you follow
to me.
that?
Well, maybe you explained it badly.
It follows distance. It follows distance.
Maybe you explained it badly. Do you want to try again?
Okay, so if we start off from the starting point from where you see the sun, I just asked you where you see the sun.
Let's say that I am standing at the North Pole, right?
Okay.
I see the sun, and let's say I see it, well, let's say I'm a little bit away from the North Pole so that directions make sense.
You're not going to see it in the south.
Well, sure you can. So if you are, say, like, I don't know, a mile away from the North Pole, depending on the time of day, you can see it in the north, in the south, in the east, and in the west.
I would disagree because we just agreed. We just agreed that because we just agreed that the sun goes in a circle. So if the sun goes in a circle, at one point there's night and day, correct? There has to be night and day.
Not during the summer. If you're in the Arctic or in the Antarctic, no, there's no night and day. It's just day.
Okay, so
daytime
at
the whole
that
time.
point, at that point, that goes back to my argument. The sun is stationary. Halo.
No, it's not stationary. It just goes around your head.
Oh, it's going around stationary.
It can't be stationary if it's also going around.
So you're telling me just like it could be curved.
Here, let me show you. Let me show you a video, a time lapse. Here, this is from the south, but it's basically the same idea.
Okay.
Hold on. Let me show you. Here's a time lapse.
Go around the circles. Yes, I see in this video.
So see how it's not stationary?
But what I mean by stationary is by that one area. You see how it's not dipping nor is not rising.
Oh, no,
it's
it
going
is.
in
It
a
is
circle.
rising and dipping, actually. See, it's higher now than it was just a minute ago.
No, because it's coming closer to the person. We're going in circles here. It's not rising or dipping. It's going in a circle, like we said.
So this is higher.
For it to dip,
it is now higher in the sky. So just as a comparison. See how it is higher in the sky here than it is here?
No,
Okay, so
it's not higher. It's closer.
it is at a higher angle, right?
No, it's closer.
The angle is bigger.
No,
Bigger
it's
angle
closer.
here, smaller angle here.
No, it's closer. It's
This is
closer.
like-
That's the only difference. It's closer. It's
It
not
being
higher. It's
closer-
closer.
It being closer
It's
can make it
closer.
appear higher at a higher altitude, like at a, sorry, not altitude, at a higher angle. That's what
Again,
like that can happen.
Observation states.
So like
as your
high
camera
angle,
is moving.
you have to point your camera up to see it here, and then you only have to point your angle less up to see it here. So it's at a higher angle, right?
So no, again,
You have to point it more up to see it here than you do here, right? Like here, you don't have to point it very high up.
Again, you
But
see the
here,
mountain.
you do have to point it
So
very
you're
high
telling
up.
me okay. So if you're telling me right there, right? You see how it's at the top of the mountain,
Mhm.
right?
Over
You're telling
here,
me
this would
as
be way above the mountain.
it would be way above the mountain, right?
Yep.
But so it got closer to you, correct?
Well, no.
Oh my God.
I mean, not in real
How
life. In
didn't
real
it?
life, the distance is basically unchanging.
But this is real life. You're saying it's not real life when we're observing this together. It's not real life.
Well, I mean, like in real life, the Earth is a globe, so like, the distance is
no,
not changing significantly.
This is your theory, bro. I'm just saying that if you're stating
It's
it
not
gets
the
higher.
distance
No,
that makes it
I'm
appear
saying
higher.
it's
No.
closer.
No, it's not the distance that makes it appear higher. It's the relative angle that you have to the sun because of the tilt of the Earth that makes it appear higher.
You just prove you again stated these are your words that it gets closer.
Those are not my
all
words.
it's doing in the
I don't know
video,
what
all it's
words.
doing
Are
in
you
the
having a
video
separate
is getting
conversation
closer.
from me? Because those were not my words.
No, those are my words.
Those
They're
are-
getting
then why'd you
closer
say that
in
they're
the
my
video. You're
words?
saying no, they're my words. You're saying
Yeah,
that
your words are wrong.
they're my words. You're saying that in the video it's getting higher. No, it's getting
It's getting higher in
closer.
the sky. Higher in the sky
No,
means
it's
that the
getting
angle above the
closer.
horizon is bigger.
Let me ask you: if something is, if
Wait, do you
something's
understand
going
what I
around
mean
in
when
a
I say
circle-
that it has a higher angle?
What you said? If it has a higher angle,
Yeah. Do you know what that means?
it basically a 90-degree angle.
No.
It's vertical.
No, no. So you can have something that's 10 degrees above the horizon, or you can have something that's 40 degrees above the horizon. The thing that's 40 degrees above the horizon is higher than the thing
Based
that's
off
10
of
degrees above the horizon.
observation. Based off of that person's observation, yes.
Are you confused? Like that's just what we mean by higher angle.
Right. And by standing by a higher angle, that in that video, it shows that the sun is getting closer. It's not that it's getting higher.
No,
Where
it
it's
doesn't. Wait,
rotating.
hold on. How does it show that it's getting closer?
Again, we just agreed that it's rotating above. It can't go higher. I mean, it can't come lower and it can't go higher because it's rotating above.
The angle can change depending on the orientation of the Earth.
The angle can only
Like
change.
whether it's a low angle or a high angle, the angle can change depending on the orientation of the Earth.
And based on the rotation, correct?
Yeah.
So if you're
Rotation
standing
of the Earth,
still,
by the way.
So if okay, we're gonna go with the rotation of the Earth. So if you're standing stationary, right,
You're
and the
just standing
sun
on the
is
Earth.
and the sun is moving in a circle, right? Is it going up or is it going down?
So in my model, the Earth is rotating, the sun's not moving.
The Earth is rotating, but in that video, it shows that he's clearly standing still and the sun is moving.
Yeah, but that's because he's on a thing that's rotating.
He's what is he on?
The Earth.
Oh my.
The Earth is rotating.
Oh, why can't it be the sun moving?
Because
You
that's
just
not my
stated
model.
your own words. Your own words was the sun
not
is
my model.
rotating above.
Yeah, from his
That's
perspective.
what you said.
From
The
his
sun is
perspective, but that's not
rotating above.
what's actually happening. That's just his perspective
Oh
because he's on a
my.
rotating thing.
Okay, you're right, boss.
I'm glad we agree. Oh, he left. I can't believe he ran from that. It's so embarrassing. Okay. By the way, sorry, one sec. All right. Yeah, we currently have an issue. I guess I don't know. Are there any mods watching TikTok right now? That's something that we need to keep an eye on. All right, let's read some super chats and then we'll move on to our next guest. From Blancs with the $5, if there's an edge that's different, if you extend that out enough, do you just not end up with a back at a globe again? Yeah, you do. Okay, Josh, thank you. There was a guy who was spamming like racist stuff and it didn't get muted. So from Johnny Carter with the $2 New Zealand dollars, super chat. Indeed, super chat. From Eric with the $5, never would have expected this kind of confusion from a guest who's smoking a blunt in his profile picture. Truly inexplicable. Yeah, right? Very, like, that was crazy. All right, let's talk to Spaces is.
Hello.
Spaces, how's it going?
Good. How are you doing?
I'm doing all right. What shape do you think the Earth is?
Good. Well, I can prove to you it's flat, and it'll only take me like a minute. I can also prove to you that the moon landing was staged.
Yeah, prove to me that it's flat. That'd be great.
Okay. So
is this going to be a syllogism, or is it just going to be like kind of like a informal argument?
I don't know what the first one means.
Okay, then I imagine it's going to be an informal argument, but that's fine. Go ahead.
Okay. Anyway, so the Earth's covered in like 70% water. You'd agree to this?
Sure.
Okay. Is the water carbonated?
Get out of here. We've all heard the joke. It's not funny. TikTok people, ban him. Ban him off TikTok. Block him. I never want to see him again. Christopher, how's it going? Christopher? 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 The joke is pretty obvious. It's like the Earth is 70% water. The water's not carbonated, therefore the water's flat. Blah blah blah. Because flat sodas aren't carbonated. Like, it's a dumb joke, and we've like, you're not original. Bad joke. I've heard it 100 times. You're not opposition. Don't come up. Let's talk to Gustav. Gustav, how's it going?
Hello, bro.
Gustav, what shape do you think the Earth is?
Nah, bro, I'm just taking a shit, bro. Just wait, just 2 seconds.
Okay, come back when you're done. Let's talk to How To.
Hey, can you hear me?
How To, how's it going?
Very good. How are you doing?
I'm doing okay. What shape do you think the Earth is?
Oh, it is topographically level, motionless plane.
Okay. Why do you think so?
It's quite obvious. That's the observable evidence.
Observable?
Yeah.
How do you figure?
I'll just look around.
So is this just like, it just looks flat? Is that the argument?
No, no. Do you believe that the Earth is traveling at 1.7 million miles per hour?
Mm-hmm.
Is it?
Relative to the cosmic microwave background radiation, yeah.
What do you mean by relative? You are experiencing 1.7 million miles.
Speeds are relative, right?
What speed is relative to an observer outside the frame, but you are in the frame.
Speeds are always relative.
It is, but not. It is always. It is relative based on the frame in which you are.
Yeah, that's what it means to be relative.
Yeah, it is. That's fine, but
so
that statement
yeah,
doesn't.
From my reference frame, of course, it's not moving at all.
Exactly, you're in the moving reference frame.
Yeah.
Exactly. So when you're in the moving reference frame and you are moving at 1.7 million miles in 13 vectorial directions, how in the good world that you won't feel any of it?
Well, in the moving reference frame, if you're moving along geodesics, you're not going to feel it because geodesics are free fall, and that's
really
that's the motion that we're along. Yeah.
Okay. Let me ask you this.
Hey, Hal, I'm trying to explain something. Please don't interrupt. From the perspective of the cosmic, or from the reference frame of the cosmic microwave background radiation, this is the co-moving frame. Somebody in that reference frame would see the Earth moving at, however fast it is, like 1.5 million miles per hour or whatever. From the reference frame of the Earth, which is almost exactly a geodesic motion, then that motion would, A, you wouldn't observe your own motion because your motion relative to yourself is always zero, and B, because you're moving along nearly a geodesic, you would notice almost no motion at all. You can unmute now.
Can you hear me?
Yeah, I can hear you.
Okay, so the orbital motion of, like, you're on the Earth moving at 1,040 miles per hour.
I'm
you
not.
know yeah, well, you are. That's what your globe sign says.
No, that's
well,
not. I mean, I'm not on the equator, so.
Well, if you're in the United States or on the 34-degree latitude or so, you're going at 750, 730 miles per hour. Big deal.
Yep.
But here's the big deal. So now you say that you're moving at you're spinning at 730 miles per hour, orbiting around the sun at 67,000 miles per hour.
Yep.
The sun is dragging you at 500,000 miles per hour, and the whole damn system is going at 1.2 million miles per hour around some great attractor, right?
No,
so
not
just
around a great attractor. No.
Yeah, that's what you can search your religion. It says that.
No, the 1.2 miles per hour is relative to the cosmic microwave.
1.2 million miles per hour.
Yeah, you're right. 1.2 million miles per hour is relative to the cosmic microwave background radiation.
It's
not relative to the. It's not relative to the great attractor.
Well, it doesn't matter. I'll give you an example.
Well, I mean, you should at least know the thing that you're trying to make fun of.
I know exactly what I'm talking. I got engineering background. I know you have a PhD.
You have an engineering background, so that means that means that you don't know anything. You just know how to use a calculator.
Why don't you give it?
That's fine.
Why don't you tell me?
How and why?
Yeah,
do you know what geodesic motion is?
Well, I don't have to know everything. Okay, just like you don't know everything.
I thought you knew everything.
I didn't say that. I didn't say that.
Okay, so if you don't know what geodesic motion is, then you wouldn't understand that the motion around the. That's okay. I have four. That's okay. I have 3 physics degrees and 1 math degree.
It doesn't matter. I already heard you debate before. I've seen you debate.
If you don't know what geodesic motion is,
I'll tell you why you.
I understand. I understand that this is really frustrating for you.
Let me ask you this.
I understand that this is really frustrating to you.
Okay, listen.
You're at a 10?
No.
You're at a 10?
No.
Take it down to like a 4, okay?
Okay. Let me ask you quietly then. Is angular velocity acceleration?
Yeah, sure.
Yes, if it is angular velocity is acceleration, how do you claim
in Minkowski space? In Minkowski space, I should say, by the way. But go ahead.
Well, listen, I don't need your big gibberish terms, okay? It's all fucking
gibberish
fake, most all of it. Okay, so let me.
You don't know what Minkowski space is?
Let me ask you this: Is acceleration has got two? Is acceleration linear or circular in nature?
You can have acceleration of any kind.
Exactly. You can have linear acceleration. You can have orbital acceleration.
Angular acceleration. You can have angular acceleration or tangential acceleration. Yeah.
So why is it that if you're in a car and you're driving around at 70 miles per hour, this is that you don't feel it because you're traveling just around a linear path. But in this case, the ball is spinning around 360 degrees.
Yeah.
Right. But you're telling me that
I don't feel. No, let me finish it.
I'm talking right now. So you're telling me that. I'm telling you piece by piece. So you're telling me that if I'm spinning around 360 degrees because remember, it is not even linear. It's not linear acceleration either. It is orbital acceleration.
Absolutely.
No, I'll tell you why. Because along the elliptical path, the Earth is also spinning, going faster as it is going farther in and out. You can look into all the religion.
Yeah. So you're confused about GD6. So let me explain. Let me explain.
Well, okay.
So the motion of people, like the surface of the Earth relative to the center of the Earth, that rotational motion, that is absolutely non-geodesic motion. So that actually does affect and is. Hold on, please. You said you'd let me explain.
I'm sorry.
That is non-geodesic motion and is measurable by scales. Actually, the non-geodesic motion basically causes you to feel slightly less heavy if you're on the equator compared to where you would be at the poles, for example, because of the centrifugal force. It's about point It's like it's 0.3. It's 0.
All those numbers are. It's not relative to me because numbers can be anything. You know,
so
I get the point.
Numbers can be anything. I mean, but it's very small. So you're not gonna like feel it per se because like there are bigger forces on us at all times. So that force is very small. The centrifugal force or the inertial force.
So my next question is why is it that we don't feel the centrifugal force while we are spinning around? Why is it centripetal in nature? Why is gravity centripetal in nature?
If
gravity is centrifugal in nature, you should be thrown
gravity
out.
is centripetal.
Exactly, that is what I said.
So that's
why
what we do
is gravity centripetal in nature?
We do feel it.
Well, what makes you think that you feel gravity?
Why do you think that you feel heavy in the morning? That's gravity. That's your weight.
Because I have a mass. Because I have a mass.
And that mass. Why does mass cause a force?
What is it?
Why does mass cause force?
Why does mass cause force?
Yeah.
Gravity is not even a force.
Sure it is.
Who told you that? Einstein, in your own religion, it says gravity is. Do you want me to send it to you?
No,
Einstein, in his own words, said gravity is not a force.
Gravity is as much a force as the other forces are, and I can prove
no, it is
but
not.
I imagine that you don't know what Yang-Mills fields are, so you probably wouldn't understand it.
Listen. When I can debunk somebody like Einstein's bullshit theory of relativity.
I'm sure you can.
And you're giving me new names. I looked at the Cavendish experiment of the big G and the small g. It is using circular reference in the calculation itself. They literally took the Coulomb's law. They literally took. Let me hear you out. They took the Coulomb's law. I'm sorry. They took the Coulomb's law and literally modified it. It is so clear the whole thing is fake.
Well, considering so you know that Newton's universal law. Hey, so how and why? You know that Newton's universal law of gravitation predates Coulomb's law.
Oh, no, it is. No, Coulomb's law was 8 years prior to the Cavendish experiment. That literally calculated
the Cavendish experiment was like 80 years after Newton wrote down his universal law of gravitation.
Can you show me? Okay, the answer to that is this. Can you show me in Newton's Principia Mathematica anywhere that he has calculated G to be 9.81 meter per second squared?
Oh, that's
650
not the
pages.
Claim. That's not the claim.
Listen, there's not a single place where he has stated.
You're saying that
you just said that Newton did, Newton did that. You just claimed Newton did this and Newton did that.
So how
Newton never gave the value of gravity.
Wow. Look, I have to mute you because you can't actually let me have a conversation with you. So look, your claim was that Cavendish just copied the Coulomb's law, which like the form of Coulomb's law and the form of Newton's universal law of gravitation are very similar because they're both inverse square laws. They both have infinite distance. They're carrying particles or masses, all of this stuff, right? So they both go as some constant times some charge times some other charge divided by distance squared. That is the strength of the force. Now that's true for both Newton's universal law of gravitation and for Coulomb's law. Newton's universal law of gravitation taking that form is earlier than Coulomb's law taking that form. Newton's version, that it goes as the inverse square of the distance and it goes as the product of the masses, that predates Coulomb's law being written down. Now it's true that the Cavendish experiment that measured the value of the constant, that came after Coulomb's law, sure. But that doesn't mean that the actual relation between distance and mass and force was copied by Coulomb. It couldn't have, because Newton had it before Coulomb did. You can unmute now. You can unmute. I invited you to unmute.
Oh, can you hear me?
I can hear you now, yeah.
Yeah, sorry, my bad. So what I'm saying is, Cavendish was the one who literally derived the values of 9.81 meter per second squared and whatever that 0.5846 10 to the power minus 13 or whatnot for the big G value, for the universal gravitational constant. They both were derived at the same time using circular referencing between both the equations. I looked at the derivation for it. And then to top it off, I find out that he's literally taking Coulomb's law and he's playing with his little stupid balls and trying to name something based on Newton's theory of this falling apple and all that bullshit. It is basically very simple. It is mass falling in a relative medium based on the buoyancy and the electrostatic acceleration, which can be measured and can be repeated and manipulated. And there's an MIT lecture on this extensively. So I don't need to listen to bullshit.
You seem a little confused about my claim. So there's two separate things here, right? There is the proportionality that Newton wrote down. This is the proportionality that the gravitational force goes as the product of their masses divided by the square of the distance between the masses.
Yeah, well, that law exists.
That's what Newton wrote down. Chill, bro. That's what Newton wrote down. And Coulomb's law takes a very similar form. It's the product of the charges divided by the square of the masses, or divided by the square of the distance. However, Coulomb's law, that relation, comes much later than Newton's law, describing the proportionality between the force and the product of the masses and the square of the distance. Now, what Cavendish did, by the way, the 9.8 meters per second, I think that was actually done by Galileo. The thing that Cavendish did is he measured big G, or more precisely, he weighed the Earth. But the way that we would understand,
how do you weigh the Earth? How do you weigh the Earth? Can I ask you?
I'm explaining.
I'm sorry. Yeah.
The way that he weighed the Earth is he took what he understood the density of the Earth to be, and then he calculated G times the mass, because they knew how big the Earth was.
How do you calculate the density of the Earth?
He
How do you calculate the density of the
just
Earth?
guessed it. He basically just guessed it.
Exactly. I'll tell you one better. I'll tell you.
How do you want me to actually like finish explaining anything, or do you just want to interrupt and like cry the whole time?
I really appreciate. Thank you.
Yeah. So he was basically just kind of like inferring the density of the Earth, but you could go look at his work. I don't know the details of that. But
I did. I already looked at it.
So why are you interrupting me still?
Oh.
So look, in modern language, what he was doing is he was calculating big G based off of the masses of the two lead balls. He understood that to mean weighing the Earth. But if you know the mass of the Earth, then you know big G, and they in some sense already knew the mass of the Earth.
In some sense.
Yeah.
And what sense is that?
In the sense that they knew how big it was and they knew what the average density was.
And how do you know that?
How do I know how?
Yeah, how do you know the mass of the Earth? How do you know the density of Earth? Let me give you an example. If you look into the Cavendish experiment, if you look into the Cavendish experiment, he literally took 5 times the weight of the water, and he took the weight of the water and the density of water and multiplied it by 5 times, and that's how he literally assumed the mass of the Earth.
Well, no.
It is so stupid. It is so stupid.
Sorry. So how do I look? So once you've measured what big G is.
Oh, you cannot. First of all, you have to tell me how the big G came around.
Once you've measured what big G is using the Cavendish experiment.
Have you looked into the equation for big G? Have you looked into the equation for the big G?
Yeah, it's the force times the distance squared divided by the product of their masses. Yeah.
Yes. Okay.
So once you've
so where do you get the mass from?
You can measure the force pretty easily. You can measure the force pretty easily.
Where do you get the mass from? How do you get the mass?
You can use like Avogadro's constant if you want, and you can multiply it by the size of, or by the size of the.
That doesn't matter. How do you get the mass of the Earth?
I'm not telling you. We're not talking about the mass of the Earth. We're talking about the mass of the two lead balls.
Because it's used in the equation.
We're talking about the mass of 2 lead balls.
Yeah, well, no, I'm talking about the big G. I want to know how you came up with
I'm explaining to you how we figured out the product of big G and the mass of the Earth. That's the thing that he was calculating. It's called the gravitational parameter for the Earth. So if you want me to explain, I can do that as long as you don't interrupt. So you do the Cavendish experiment with 2 lead balls with known masses. You can calculate the force between them, which is what he did. You can measure the distance between them, which is what he did. You can measure the mass of these things, which is what he did. Then you can take that force, divide it by the product of their masses, and multiply it by the distance between them squared. That will give you what big G is. It's a constant.
Oh, really? I looked into the equation.
Sorry, I'm not done. I thought you were going to not interrupt. Then once you have big G, then you can solve for the mass of the Earth. If you know what the gravitational acceleration down is, that's measurable. It's 9.8 meters per second. You can take that big G. You can take that acceleration. You can multiply it by essentially the size of the Earth, which is 4,000 miles in radius or so squared.
Yes, 3959.
And that will give you the mass of the Earth, times big G. And you already know what big G is, so that gives you the mass of the Earth.
Yeah. But when you look into the equations for the derivation for big G, you can see that they are including the mass of the Earth, which is completely based on 5 times the weight of water. I just told you how
you can do this.
I just told you because you just say that we got the big G, and then we got the small g, and then we found this everything. But when you go look into the big G equations and you see the parameters, the variables they're using, it is ridiculous. They are assuming shit.
So you know that the way that you calculate big G nowadays is by doing a Cavendish experiment with 2 known masses.
Because remember, well, I agree what you said. Whatever is done right now is not what matters. What matters is.
But we can do it now. So why are we relying on something written 300 years ago?
Well, the way it goes is you guys believe in the ball because Stodney some 2,000 years ago went around with a little stick in Alexandria and he figured this thing out. That's what you guys stick to.
Are you currently having a manic episode? Because you seem
I'm
really
not having,
upset about this.
See, these things are very rigorous. I'll give you another one. Can you tell me how is the 62 column of atmosphere literally velcroed to the Earth?
I don't know what you just said. Can you tell me how what?
So you tell me. You just think about fluid dynamics, and just think they're telling you when a helicopter is picked up at 1,000 feet altitude and it is hovered for an hour, and when it lands back to the same place because the helicopter is moving with
You're
the
an engineer,
atmosphere.
right?
Yes, I am.
Okay, so you understand
yes, I am. I have a $2,000 challenge. Anybody
so
who can
you understand how relative motion works, right?
What were you talking about? I'm just asking you, how does fluids work?
I'm just checking. So wait a minute. Did you take a fluid mechanics class? Because I'm happy to talk about this.
No, tell me, do you believe in drag coefficients?
Yeah, sure, absolutely.
Is there a coefficient of drag for wind, for atmosphere, as it flows over the Earth's surface?
Yeah, there is.
Yes, if it is so, why is it going in lockstep?
This is called the no-slip condition, by the way. It's pretty well understood in fluid mechanics. You're familiar with no-slip?
Yeah, well, listen.
Do you know
Don't throw me
what the
around.
no-slip condition
I'll
is?
get you right on. I'll get you right on the point.
Do you know
So
what
you're
the no-slip
telling me.
condition is?
Listen. You just answer what I'm asking you. You're the
How and why?
expert here, right?
Look,
So,
I gave you an
so
answer,
you-
but it seems like if you knew what it was, you would understand the answer. Do you know what
No,
the no-slip condition
listen. I
is?
don't need. Listen. You just listen to me.
Do you know
first.
what the no-slip
I
condition
want you
is?
to explain. I want you to explain to me how is a 62-mile column of atmosphere right on the Earth's surface, a square inch over, moving in lockstep when you can see the wind violating that directional flow in every which way. Smoke
do you know
coming
what
out
the
of the
no-slip
chimney
condition
violates
is?
it. Well, I don't care. You just explain it to me how it happens.
Okay, so
You just explain to me how it happens.
The no-slip is about the no-slip condition. It's a boundary. We can just read it. In fluid dynamics, the no-slip condition is a boundary condition which enforces that at a solid boundary, a viscous fluid attains zero bulk velocity. Do you understand that?
Yeah, I get it so far.
Okay, so is air a viscous fluid?
Well, of a sort.
Okay,
There
so
is some level of viscosity.
Air has a non-zero viscosity, so it's a viscous fluid.
How do you know that? Depends on the density of the air. Depends upon the molecular composition of it.
So all non-superfluids are viscous.
Okay, what's your point? Just
so
get
air
to the
is a
big point.
viscous fluid, which means that the relative velocity, that's what the no-slip condition is, the relative velocity between the air at the Earth, like when it's touching the Earth, and the Earth itself is zero.
I get it. Yeah,
Okay.
I get it. So I'll give you that much.
So so then you can you can project that no-slip condition up.
Whoa, that's where you go wrong. You know why? Because you go layers. Listen, let me
otherwise
finish.
there will be a
I'll give you
relative
chance.
speed between the two.
I'll give you a
Between
chance.
relative.
You can take. No, let me finish it now. I'll tell you why it is not. Because at the very surface of the Earth, I can consider it to be moving at 1040, being at the equator point.
Yep.
But as you go higher and higher, there is a drag. You literally can do an air. I
You mean
work in
wind?
aviation.
Do you mean
and
that there's wind?
Of course.
Yeah,
Wind is a
there
part
can
of
be
the
wind.
atmosphere.
Wind is a secondary effect, absolutely.
Oh, so wind is a secondary effect, but atmosphere is not a part of the wind. So are you telling me atmosphere is not a part of the wind?
No, I'm not telling you that.
Are you telling me that?
I'm not telling you that. Do you want me to tell you what I'm telling you?
Okay, yeah. You just said it right now.
So there is the bulk motion. So there's the bulk motion of the atmosphere. The bulk motion of the atmosphere. Please.
Yeah.
You want me to explain? You should do that without interrupting. Have some manners. I imagine that your mother taught you better.
Okay. Thank you.
Sure. So there's the bulk motion, and then there's perturbations to the bulk motion. Those perturbations are what we call wind.
Oh. Perturbations are we call wind. So there is violation within the system when you say that it is moving as a rigid entity, which is the atmosphere, which comprises
That's the bulk
of air.
motion. It's the average motion.
Yeah. If it's the bulk motion, why is it that if a helicopter is to hover for 1 hour and still come down and be exactly at the same point? Why is it that Felix Baumgartner, when he jumped 23 miles down, why does he come back literally 30 miles out? Okay, because you're just trying to adjust the numbers and you're throwing in stupid logic.
Do you want me to explain?
Right? Yeah.
Rather than working yourself up and insulting me, because obviously that's what's happening here, you're getting upset.
Well,
You can just ask the question and not say, because your stupid logic, blah blah. Like you can just ask the question and then I can answer it.
Listen, you just said the point I'm asking here is this: you cannot in any way explain away a 62-mile column of air, because the Kármán line starts at 62 miles, like the fakery is all about. For apparently. But if you take a foot by foot, a cubic foot on the Earth's surface, and you stand up a column of 62-mile column of air, I'm supposed to believe that column of air is literally going through all the 7 resolved vectorial directions, 1.7 million miles per hour, and it is not budging an inch. But apparently, the wind is cutting through it every which way, and the smoke that is coming out of the chimney is drifting away. All that is getting violated. But apparently, if somebody were to hover in that square feet of land 62 miles up above for 1 hour and then come back down, they exactly come back to the same point, because apparently the atmosphere is moving lockstep at 1.7 million miles per hour.
Do you want to like actually let me explain rather than just asserting that I can't explain?
Now you can explain. Now explain how this is correct.
So in a helicopter, you are not going to end up hovering over the exact same place if you just take your hands off the controls, right? If you want to hover, this is an active process, right? Helicopters have to put in inputs to make sure that they maintain over this. Yeah, absolutely it is.
You can lock it in place.
No, you can't. I mean, like there might be autopilot that will do that for you, but absolutely.
Yeah, exactly. I work in that industry.
Right. So there are active components that have to adjust to maintain your location, right? Like this is not something that happens passively. So I mean, you're right. There like absolutely is like wind. Wind is a real thing. And so this is, if you wish to hover, you have to account for that. That is accounted for by the either the manual inputs that you're giving, or by the electronic, like the fly-by-air electronics that you have in the aircraft that you have in order to maintain your position. And this is why, because there's no physical like control surfaces on Felix Baumgartner except his wingsuit. This is why he ended up off where he was intending to be, because he can't control the wind.
He drifted because of the wind.
Basically, yeah.
Yeah, that's it.
So he drifted because of the wind.
And the reason why
helicopters. Sorry, I was still explaining. The reason why helicopters are able to hover is because they have active control surfaces that can adjust for the wind. So it's really not that complicated to explain. You don't have to adjust for 1,000-mile-per-hour wind, because there is no 1,000-mile-per-hour wind. The bulk motion motion of the air relative to the ground is fairly low. Depending on your altitude, it can be up to maybe 100 miles an hour or so.
Pause right there. Are you going to consider the rest of the forces acting and the speed velocities that is under consideration?
There are no other tangential forces,
because
no.
You can imagine, anybody with a common sense can imagine, if there's a column of air over a particular surface area, and that is having a rotational speed, that column of air, 1,040 miles per hour at the equatorial point, and then to tag along, they have a 67,000 mile
we've been over
force.
that, though.
Yeah, well, no, I'm just saying, all these forces are acting on that column of air.
Those aren't forces.
No, force by virtue of its motion.
No. So
it is a reactionary force. Listen. Let me
when
finish.
You're in orbit, when you're in orbit, there's no centrifugal, there's no centrifugal force.
What? You cannot claim that, because otherwise your gravity is suspect. If you claim centrifugal force exists, then you cannot explain gravity. So you have to call.
What do you mean?
You have to call it as if it doesn't exist.
No, you're
so stupid.
confused.
Just think about it.
You're confused.
No,
Let me explain.
I'm not confused. Gravity.
You're absolutely confused. So orbital motion is
Yeah.
along a geodesic. You don't feel geodesic motion.
No, what makes you say that? What's the claim?
You just made a claim. How are you going to prove
relativity. Oh, well, just because general relativity theory has been just trumped up doesn't mean it has to be right.
I mean, it's been tested, so.
Oh, how was it tested?
By the Gravity Probe B experiment.
Well, what is it? Some kind of a control experiment? Why is it not? It's commonly, anybody with sense would think about it. Nobody experiences 1.7 million miles per hour speed. You just claim that you have some.
It just sounds like you were just taken aback. This is a real experiment. It was conducted between 2004 and 2006.
Well, the Cavendish experiment was considered to be a real experiment too, but it's a stupid experiment.
I am sorry that you feel that it's a stupid experiment. This must be why you're an engineer and not a scientist.
Yeah, of course, because I can disprove it.
Because you don't understand experimentation. I got it.
I saw the small g and the big G, and I compared it to the Coulomb's law, and anybody with a 10th grade education can debunk it. I don't need a PhD or an engineering degree to figure that out.
I wouldn't be surprised if you don't have one.
So
look.
No, I do have three.
The Gravity Probe B experiment. The Gravity Probe B experiment is a real experiment that happened. It was conducted between 2004 and 2006.
Just like the Cavendish, but go ahead and say it.
It's a physical experiment. You can go look. You can go look it up yourself. I can pull up a link for you if you want.
There's plenty of things to look it up. There's a lot of fakery out there.
This is a real experiment, and it tested very specific predictions of general relativity that are not present in Newtonian gravity. And it just follows, like, they matched the predictions to the T. So, like, I don't know what more you want. Like, this is a real experiment that matched the data.
Yeah. You're gonna give me an experiment just like Cavendish did, with a stupid gibberish
Are you just telling me that like the experiment was fake, or like what's the contention
of course.
here?
Don't you think if there's so many pseudoscience papers that's being written up, what makes you think that these scientists are all publishing the right thing? People sell out for money.
We're doing science denial now. Okay, cool.
I heard that you're an influencer for the globe theory too.
So we're just like doing science denial now. You're just like, it's just all fake science. It's not real. It's made up.
Listen. It's no. I'm talking science because
apparently not.
Because you can. It's very simple, man. You take fluid in a container, and if you spin the container, the fluid will follow with the lag. The fluid always follows with a lag, and the lag decreases over time. So you're telling me this bulk motion and all this bullshit? Huh?
No. There's a distinction there, and it's actually a good point that you bring up. The reason why it's going to follow with a lag is because there's another condition at the center, namely that there can't be motion at the center of your container, right? So the velocity at the center has to be 0. And so that's that is a boundary condition that you must impose when you're solving the fluid dynamics equations. However, if you have the fluid on the outside of a thing that's spinning, that boundary condition's not there. So the system of equations you have to solve is different. So you will get different behavior.
Yeah, what are you talking about, man? This is just an observable evidence I'm talking about.
Okay, so you didn't understand anything. I highly doubt that you have any degrees in engineering.
Well, it doesn't matter. I know that you have a fake PhD degree and you're a paid influencer for the globe theory. I've seen your debate. No, I'll tell you why. I've seen your debate. Listen,
I've seen you. Hold on, now I gotta know who's paying me.
I don't know. There could be anybody paying out there telling you all kinds of shit to say on the stream, and people believe it because you throw these big technical terms.
So you say I'm paid, but you don't know who's paying me?
No, well, that's the general consensus. I listen
it's
to
the
your
general
debate,
consensus that I'm paid. Is it like Big Globe that's paying me? Is it like the Globe manufacturer? Is it NASA that's paying me?
I don't know. Yeah, maybe because I got plenty of CGI videos on NASA that shows how fake it is.
Me?
So I'm saying you can just go and find it yourself. You can look at thousands of videos. I can go and
find who's paying me myself?
Yeah, no. I'm talking about you can look. You just said NASA. You can look at CGI videos of NASA. Endless of them.
I'm asking who's paying me.
So I don't know, man.
You know who's paying me? You know who's paying me?
I cannot.
Look, I can actually answer your question. How and why? How and why? Can I answer your question? You know who's paying me? Look, you want? I gotta answer your question. You gotta let me answer your question. You know who's paying me? People who are watching, like the probably 2,000-ish people who are watching, are paying me to destroy people like you and make people like you look foolish.
No, you cannot. You cannot do it, man. Listen,
that's who's paying me.
Listen. The globe theory has been debated in the court and lost twice. Really? So all you can do,
of course.
Yeah.
Because obviously that's not true.
Oh my God! Why don't you go search it? It's right there.
I'm familiar. It's so there's a there's a very famous court case.
It has been lost twice.
That's it didn't lose. The Globe didn't lose. Do you want to go pull that up?
You know, he paid $15,000 for compensation on it, I believe.
Do you want to go look that up? You want to just?
I don't. Listen. I got a regular job to do, right? So
I'm sure you do. Oh, you're running.
I just don't have time to sit like you. And bullshit to people and make them believe this shit.
Running.
I got a real aviation job to do.
A real aviation job. Hey, tell your boss that you think the Earth is flat.
Well, he already knows it.
Oh, okay. I'm sure he does.
People know it, man. Anybody who has common sense knows that we are not spinning at 1.7 million miles per hour. Only people like you with your gibberish science believes that we're spinning at 1.7 million miles. It's ridiculous to even imagine that.
You should go learn some GR. That'd be really, really neat.
I don't need to learn anything. No,
of course you don't need to learn anything. Because you're a flat earther and you know everything.
No, I don't need to learn anything. The one that you are trying to tell me.
Of course you don't need to learn anything.
No, because listen, because it only takes common sense to figure out all these bullshit PhD science that talks about orbital mechanics, three-body motion problem, three-body motion problems, and all these kinds of anomalies existing everywhere. Huh?
Are you talking about Thompson versus Garcia?
I don't know who the fuck that is. I really don't care to know.
I thought that you knew about the court cases.
Yeah. Well, okay, it could be. I don't know. I can pull it up. I can send it to you.
You got.
Geez, look, geez. Yeah.
Yeah. So you don't even know the name of the court case.
Dude, I have it all saved up on my computer. Like I said, I have a real job to do where helicopters are put together.
You have a real job to do where go tell your team lead that you think the Earth is flat.
Listen, I have level 3, level 2. No, listen, I got plenty of level 3, level 4 engineers over here. I offered $2,000 direct.
Don't tell them that you think the Earth is flat.
Give me one exclusive. Yeah, they all know it, man. They all know it. They all have common sense.
Okay, and I'm sorry, what company do you work for?
Only with stupid PhDs like you don't figure it out.
What company do you work for?
Everybody who's
Flat Earth Incorporated?
Well, no, it is called Globe Bullshit Incorporated.
That's the name of your company. That's a fake company.
Incorporated. Yeah, where I have to go fix people up and get their head straight.
I thought they had a real job. I thought they didn't do this debating thing for a job.
No, you have a PhD in whatever the physics or whatnot, and you just go around.
You have a PhD in whatever physics. It just sounds like you're salty that I have a PhD and you just have a lowly engineering degree. Sorry for all the engineers watching.
No, nobody cares. PhD. You guys just sit around. The engineers make things happen. We literally go outside, make observations, manipulate the environment, bring devices into existence.
You probably tried to get a physics degree as an undergraduate and then failed, and so you switched to engineering.
I never did, man. I would never do some stupid stuff like that.
Okay.
I will do the real deal. But I don't sit around as a bookworm reading shit and publishing pseudo papers, reading dissertations and trying to.
I don't do research. You think I'm a nerd?
Listen. I did a thesis too, right? I did a thesis too, and I know how this bullshit works. How you skew statistical data is skewed. You get consensus from the peers like yours, and publish your work, and then just get your PhD, and then become a professor in some university.
This seems really personal for you, isn't it?
It is not personal for me, man. It is not.
It definitely seems like this is like really upsetting for you,
it is personal for you because you make a living out of it.
I mean, it accounts for like something like 30. It accounts for something like maybe 30-ish% of my income. Maybe 35.
Okay, fine. What the rest? What you do? Sit in some university and talk bullshit? That's what you do. Teach young minds some bullshit science that you'll learn somewhere.
Yeah, is that a bad thing? Is teaching people a bad thing?
Right. Yeah, but teaching the right thing is a very important thing. No, I didn't say that. Teaching is not a bad thing. I said I just said that you with your PhD, all you can do is just run around, write some pseudoscience papers, get your peer reviewed.
Can you demonstrate that they're
some
pseudoscience?
Statistical data, because I did this shit, for my master's.
Can you demonstrate that they're pseudoscience?
Yeah, well, there's plenty, man. You just have to look around.
Yeah,
There's
okay.
plenty. What makes you think? Listen, if I give you $1 million,
can you find the error in my my recent paper on asymptotically de Sitter black holes, rotating black holes? Can you find the error in that for me, please? That'd be good.
Well, why don't you send the paper? I'll look at it.
Yeah, okay.
Why don't you send the paper? I'll take a look at it.
Yeah, I will. DM me.
Okay.
I'll send you the paper right now. Pull up Discord.
Why don't you
DM
drop
me,
it here?
and I'll send it to you right now.
Yeah, let me look at the bullshit that you've written in it.
Yeah. So wait, just to be clear,
you think just because you wrote a paper and got it published, that means you're smart?
I just gotta clarify, because like if you want to peer review it, like I would imagine that you'd have to be familiar with the topic.
You already got it peer reviewed by a bunch.
So you understand the Einstein field equations, right?
What? Oh yeah, I know Einstein is a fucking pedophile, but go ahead.
Well, you didn't really answer my question. You understand the Einstein field equations,
Yeah, I just
right?
answered your question. I know Einstein is a pedophile.
Okay, but are you familiar with the Einstein field equations?
Cousin.
Are you familiar with the Einstein field equations?
I know Einstein is a guy who basically doesn't have more than 3 patents.
So wait, are you familiar with the Einstein field equations?
Einstein is a guy who literally Nikola Tesla said he's a beggar in a.
So are you familiar with the Einstein field equations?
Listen, I don't need to know what a liar says.
Okay, so to be clear, like if you don't know what the Einstein field equations are, how would you be equipped to evaluate the correctness of my paper?
It's like you're trying to force me to take this guy for granted and read his work as if it's like some of the most exclusive work. He's a fucking con artist.
You know, the
He's a con
Einstein field
artist who
equations.
literally says space-time.
The Einstein field equations, man, you're really like crashing out here. The Einstein field equations were verified with the gravity probe B experiment.
Yeah, sure, whatever.
I mean, they were. You should look into it.
I'll look into it.
Yeah, you should look at the gravity probe B experiment. It's pretty compelling evidence that
Yeah, is that the one where he talks about? Yeah, space-time is curved and the ball is actually moving in a linear direction, but it is actually moving in a curved pathway, like the membrane and all that bullshit.
So like, I understand that probably the highest math that you took was maybe differential equations if you're lucky, but there's like more math than that. Yeah.
I took engineering mathematics level 3 and all that shit.
Yeah, so like that's like calculus 2, right?
It's not calculus 2, it's calculus 3 levels.
Oh, calculus.
Yeah.
Oh, okay, you took calculus 3.
I did it.
I didn't know. I didn't know that you took calc 3. Big man over here. So you know that there's more math beyond calc 3, right?
Well, math is not an explanation. Math is just descriptive
I never
in nature.
made that claim. You know that there's more math beyond calc 3,
math is just
right?
descriptive in nature. Math doesn't explain the phenomenon. I can make Superman fly.
So in order to
assume all kinds of
geodesic motion, you need mathematics.
I can assume all kinds of variables and make a Superman fly. But that doesn't mean the math is right.
So look, in order for me to explain to you,
just because you throw math to your people doesn't mean I'm going to get scared by your stupid, mathematics.
So in order for me to explain to you how and why we don't feel the motion we don't feel the orbital motion as we go around the sun. We don't feel the motion as we orbit the center of the Milky Way. The reason why I need mathematics to explain this to you is because geodesic motion is described mathematically. That's the language that we use to describe geodesic motion. If you don't understand geodesic motion, I can't really help you. You could go take a class. It might take you a few years because obviously your brain is smooth enough that a koala would be jealous. But like, this is something that you would need to learn first before you can criticize it. Otherwise, you're criticizing something you clearly don't understand. Go ahead and unmute yourself.
Right? No, you can say whatever you want, brother, but you're not traveling at 1.7 million miles per hour. It's not happening. That is like going at 30 times the speed of sound? No way. More than that, probably. I don't know. Like 749 miles per hour is like 1 Mach? How many Machs is it? I don't even know. Make the calculation. It's ridiculous. It's stupid. And I'm supposed to take for granted because some Einstein
What's the evidence for the claim?
decided to say that.
How and why? What's the evidence for the claim?
It's not my claim. It is a pseudoscience claim.
Well, you said that it's stupid. You said that it's obviously not true. So like, why do you say that it's obviously not true? What's the evidence?
Because there is no evidence. And the only time when I ask for evidence, you start talking about the relative frame just to evade not explaining it. And nobody's going outside of it. No. You're saying that you will only observe.
And I don't think that you're smart enough to understand the explanation.
You initially said that for you to observe it, you have to go outside the reference frame. You said.
Oh no, I didn't say that.
Nobody is going outside the. Oh, you just said it in the beginning.
No.
You have to be in. Yeah, you have to be in a stationary frame.
I didn't say you have to go outside of it.
No,
There is no
of
such
course
thing
you
as
have
a
to be in
stationary frame.
Listen, yeah, whatever the frame is, a frame different from the frame in which you are, to observe the motion and record it.
So our
It's as
motion
simple as
relative
that.
to our own, so we are at rest in our own frame, kind of by definition.
Yeah, exactly. So this is where I say it's a pseudo claim, because you are
Not a
trying to put a
pseudo-claim, that's, like,
position.
obvious.
Yeah,
Obviously, we're not moving relative to ourselves.
Yeah, you can keep using the word obviously, but that still
But wait
doesn't
a
make
minute, do you
sense.
think,
You know why?
are you confused by the fact that relative to our own reference frame, we're not moving?
Relative to our own reference frame, you're not moving. I'm gonna say, yeah, of course we are not
Yeah, of course,
moving.
that's obvious, right? So, like, if you want to talk about motion, you have to go to some other reference frame.
You're telling me when I go to Lake Tahoe and I see the mountain ranges and I don't see a wrinkle in the ocean while we are going at 1.7 mile, twirling, twisting, and torquing our way through.
1.7 million miles
right?
relative to what?
Right? Yeah. No,
Relative to
it's
what?
relative to what? Listen, it's like this. If I make you stand on a Ferris wheel and the Ferris wheel spins, you feel it immediately.
So we've been over this.
You feel it immediately.
We've been over this.
Okay?
You
so,
feel acceleration only,
I never.
right? It's the only kind of
what do you
motion
mean?
that you can feel, right? We agree.
Well, I feel angular acceleration.
Yeah, that's a type of acceleration.
Not just linear. I feel angular acceleration.
I said acceleration. Acceleration covers angular acceleration.
My vestibular systems.
How and
listen,
why?
my vestibular systems are so sensitive that it immediately picks up that I'm moving in an angle.
How do I? I've looked into this. The vestibular system is sensitive enough to pick up about 1 centimeter per second squared. Sorry. Acceleration. Now, the acceleration that we get from the Earth's rotation is about 0.3 centimeters per second squared. So it's lower than the threshold that our vestibular system can sense.
Did you consider the other speeds?
Well,
you just considered the ball spinning?
The other speeds give us no proper acceleration, so they don't really contribute.
What do you mean by other speeds don't give us perfect acceleration? What are you talking about?
I said proper acceleration. So proper acceleration
what do you
is
mean
what
by
you
proper
feel.
Acceleration? Define proper acceleration.
So proper acceleration is deviations from geodesic motion.
And since you brought this term a million times, listen. I read up on geodesic, but I want you to refresh my memory on it.
Yeah. What question do you have?
The geodesic. You've been claiming on it. Let me hear it.
Yeah. So a geodesic is a path. It's whether it's through space or through space-time. It depends on what setting you're in. A geodesic is a path that obeys the geodesic equation. The geodesic equation is, in some sense, the curved variation or the curved version of the straight line condition, namely that the proper acceleration of the path is 0.
Okay, you just said in some sense.
Yeah, I was
what is that supposed to even mean in a technical word? If I say that in some sense, the helicopter...
I could give you the mathematical definition if you want, but you're just not familiar with it. I will give you the technical definition. I'm happy to. But you just won't understand it. Yeah.
Let's give it
a path gamma follows a geodesic trajectory.
What is the gamma in this case?
Gamma is the name of the path.
Okay, so you just named a path gamma. Go ahead.
Yeah. So gamma is the name of the path. So path gamma follows a geodesic trajectory if and only if.
Well, hold on. You cannot use the word geodesic.
I'm giving you a definition.
Trying to explain geodesic.
This is like saying the definition of X is, and then you cut me off before I gave you the definition.
Okay, I'm sorry.
So a gamma or a path gamma follows a geodesic trajectory if and only if the covariant derivative in the direction of the tangent velocity to the path gamma with respect to the tangent vector along the path gamma is 0.
Oh, hold on. So you said covariant path and a covariant vector.
No, I said covariant derivative, and I said tangent vector.
Okay, so what do you, when you say your covariant derivative of what you said?
I said the covariant derivative with respect to the tangent vector of the path.
Okay.
You take the covariant derivative with respect to the tangent vector of the path.
Okay.
And you act with that on the tangent vector of the path. If you get 0, then you get then the path gamma is a geodesic path.
What is a covariant in this case?
It's an adjective. It's a type of derivative.
An adjective. So
yeah,
again, it's got nothing. What do you mean? What type of derivative it is? Help me. Is it 90 degrees to it?
It's a derivative. You know what a derivative is?
I know what is a derivative. So just tell me, what do you mean by covariant?
So a covariant derivative is a derivative that preserves the metric.
That preserves the metric? Okay. Yeah. Okay.
It also is torsion-free. Well, so specifically, we're talking about a covariant derivative with respect to the Levi-Civita connection. That gives us specifying the Levi-Civita connection makes our covariant derivative preserve the metric and be torsion-free.
No, you still haven't satisfactorily explained what a covariant derivative of
I understand that. You have to
is.
take a course in differential geometry if you want to understand it better. This is like a technical subject.
Since you have the PhD and you talk bullshit in your class, why don't you explain it to me?
Do you want me to just pull up a textbook for you?
No, listen, you're the expert in this. Why don't you explain it? Just break down what covariant derivative of a gamma path is.
Yeah, so a covariant, you take covariant derivatives of vectors, you differentiate that vector in the direction of itself.
Okay. No. When you say covariant derivative of a vector, so when you're taking a covariant derivative of a vector, what is it actually you're doing?
So, do you know how a vector
What is
is
it
defined?
actually you're doing? What is the physical aspect of it?
So essentially what you're doing is you're measuring the deviation of that path from what would be called parallel transport along that path.
See, that's what I'm saying. The more I ask, the more you're just throwing out different. So now it's very simple. If it is moving through a curved path, it is in a vectorial direction and it has a scalar quantity, which is linear, whatever the speed is, and you just resolve it.
Speed is not scalar, right?
Speed is not scalar.
Yeah, it's not scalar under Lorentz transformations.
Yeah. Maybe not. That's what, meter per second, right? So meter per second, it could be, if it is going in an angular direction, its angular velocity is acceleration. It is having both scalar and a vector. If it's in a linear path, it's just going straight. I mean, say you can resolve it in the reference frame that you're looking at it. When it is moving in an angular path, you resolve along the x and y directions. So derivative is just basically taking small sections off of it and trying to find, using that. That's pretty much it. I mean, I didn't look too much into it. It's been a little while. I can read into it and figure it out.
You should. Here, let me give you a book recommendation.
Yeah.
1 sec. Let me pull it up.
Yeah, can you just drop it in here? I'm gonna make one more loop.
There's not really anywhere I can. There's not really anything I can drop. But
okay.
Don't I have a?
I can.
1 sec.
Yeah,
1 sec. I think that he has it on his website for free. Does he have
I really appreciate having this conversation. Thank you.
I'm sure you do. You might not have it on his website for free.
Like I said, man, water doesn't bend. Okay. No, column of air doesn't stick to the Earth's surface while it's traveling at 1.7 million miles in 7 vectorial directions.
Absolutely.
It doesn't happen.
Oh no, I do have a copy. I'm sorry.
Okay.
Yeah. So here's a book recommendation. I recommend it to basically everybody who wants to learn this stuff. Here it is.
Well, I really appreciate the knowledge that you have. I'm just saying, I used to
Clearly
be on the same
not.
school
You were
of thought,
insulting
right?
me for like the last 20 minutes because you were mad
You took
and
your
upset.
shots at me too, brother. I'm sorry. I apologize if I did that.
So this is the book that you should read, called An Introduction to General Relativity, Spacetime and Geometry. It's by Sean Carroll. In fact, I can actually just go show you the relevant part on what a covariant derivative is. I can show you the.
Yeah, I'm gonna run a search on Grok pretty soon. What a covariant derivative is.
You shouldn't use Grok for learning this.
Well,
So
it's basically curated source, so why not?
I think that there's a section on covariant derivatives. There should be. Yeah, there, page 94.
Yeah. So again, you see that how we get pigeoned into a small section, trying to somehow work your way. You're trying to explain your way out of it.
We have a section on covariant derivatives.
Yeah. How do you explain the gyro systems in an aircraft?
Seems like you just want to deflect away from.
No, I'm not. I get the point. I'll lean into the subject that you're talking about. I just want to quickly touch on another point before I had to get back to work.
So in flat space, in flat space in inertial coordinates, the partial derivative operators partial mu is a map from KL tensor fields to KL plus 1 tensor fields, which acts linearly on its arguments and obeys the Leibniz rule in tensor products. All of this continues to be true in the more general situation we would now like to consider, but the map provided by the partial derivative depends on the coordinate system used. We would therefore like to define a covariant derivative operator, this is called nabla, that's this thing here, to perform the function of the partial derivative, but in a way independent of coordinates. Rather than simply postulating the answer, which would be perfectly acceptable, let's motivate it by thinking carefully about what properties it should have. So it should have these properties. And this is a coordinate definition of what the covariant derivative is in terms of the connection coefficients gamma here. This is a capital gamma in this case. So in any coordinate system, we can define a covariant derivative this way, where gamma is determined by whatever constraints you wish to imply. So this is to say there is a whole section on this. You could go and learn about it, and then you would learn about what a geodesic is. Geodesic trajectory is pretty well understood.
Geodesic, I used to follow it. It's been a while. I haven't looked back into it. But sure, I'll look into it.
You should look into it, and once you look into that, then you'll understand why the motion of the Earth around the Sun, why the motion of the Sun around the center of the galaxy, and why the motion of the galaxy through space. None of these things are felt because they have non-zero, or they have zero proper acceleration.
Sure. How do you explain the gyro?
Okay, we're just going to completely pivot.
No, no, I'm not pivoting. I really am. That's not my intent. I just wanted to get your opinion
What
on it.
about the
That's all.
gyro?
Like, does the gyro? Why doesn't the gyro indicate the curvature if there is an existing curvature that the aircraft goes through?
They do. They have to be modified on the regular. They have to be adjusted to keep in line with the horizon.
How do
That's what
you
pendulous vanes are
adjust
for.
something that is already set into motion while you're on a level plane before you take your flight?
You can apply a force to a rotating body. This will, or you can apply a torque rather to a rotating body, which will cause it to change its angular momentum, and that angular momentum can then be adjusted so that it's still perpendicular to the motion of the surface of the Earth.
It's very simple. You spin the gyro on the ground at 5,000 or 6,000 RPM, then you pick up, and if you fly 100 miles straight over the Bolivian salt flats, the curvature drop or whatever that it is, 600 feet or whatnot.
Yep.
Right? It never gets registered.
Oh, you should look at pendulous vanes.
There's no compensation required for it.
You should look at pendulous vanes if you think that there's no compensation required.
Yeah, then well, listen, I know that.
So you realize that pendulous vanes were literally
just like no sniper compensates for Coriolis.
Hey, how and when? Pendulous vanes were specific devices invented to account for the fact that it does drift and they have to correct for it as they travel in planes. That's what pendulous vanes were invented to do.
Oh, pendulous vanes.
Yep.
Wow.
You should look into that. They're not used anymore because we have more sophisticated methods of doing it now, but in old
that's right.
airplanes
It's
with old
convenient to
gyroscopes,
just get out of it quick. Yeah.
No, pendulous vanes were invented to do that. They were analog ways of adjusting.
How does the pendulous vane adjust to curvature?
They essentially use wind and wind drag and the gravitational pull of the Earth to get realign the gyroscope. But look,
you cannot even get an accurate. Yeah, I know. You just said it uses the wind as if it picks up the speed from a pedostatic tube or something, and just runs it into the gyro's pendulous vane and figures out what the curvature bend is continuously happening. Do you even know the ridiculousness in this point? It
okay,
never
so
happens.
I understand that you don't know how it works, but that doesn't make it ridiculous.
Just because you have some equipment, pendulous vanes, and wind is just adjusting for the curvature as the aircraft is moving at 300-400 miles per hour, over 30,000 feet, going around, and all the speed velocities are being.
Is not particularly convincing.
No, it doesn't. The thing here is this: when I asked you how pendulous vanes actually gives dynamic compensation for the curvature that is happening at 300 miles per hour, you're just telling me that it just takes the airspeed at 30,000 feet and figures it out.
It doesn't take the airspeed.
Are you telling me it takes the airspeed at 30,000 feet?
You should just read into how pendulous vanes work then, if you're confused.
Well, I can, like I just said, mathematics. I can write to make a Superman fly.
You should just read up on how pendulous vanes work. They're not.
You can create a contraption to explain bullshit. No, but these things actually don't go into the system.
Okay, so pendulous vanes are really well documented, and if you're in aerospace, you should actually know what they are.
Yeah, really? You're telling me that pendulous vanes are built into the gyro system?
No, not anymore.
Back from the 50s.
No,
not anymore.
They used
to be. You cannot claim it anymore.
Well,
yeah,
now,
it used to be. Now,
our gyroscopes are like solids, or like a solid state now, right? Like they're not like physically spinning discs that are not controlled electronically.
There are gyroscopes that are used in the aircraft that is still spinning.
Yeah. Are you sure?
Again, the point here is
I'm pretty sure that they use. I mean, I don't know what planes you work on. Maybe you work on planes from like the 60s still, but I'm pretty sure that most planes use solid state gyros now.
Yeah, right. So what you're trying to tell me is this: I have to. So what do you tell me? No, listen.
Anyway.
Yeah, I'm sorry. So what I'm trying to just close the point out is you are telling me that I have to take for consideration these pendulous vanes are compensating for the curvature drop that is happening dynamically at 300 miles per hour, 800, 500 miles per hour, and they are compensating it so right that the deviation between the artificial and the natural horizon set state is always maintained zero. And you cannot, pilot and the co-pilot sometimes cannot even get a proper temperature reading at a set velocity up at whatever altitude from the temperature and the velocity of the wind that they gauge from a pedostatic tube. And I'm supposed to believe such a precise curvature drop calculation is gauged from some pendulous vane structure that is built into this. You don't even know what they are,
so it sounds like you should probably just.
You just told it to me.
Yeah, so you should probably just look into it before saying that it's ridiculous, right?
No, so you just told me it is some kind of a contraption that takes the wind and just gives you the accurate reading.
Well,
and I'm supposed to just take it on faith.
Yeah, you can look into it. Look. I mean, the responsible thing to do is for you to be like, If that's an answer, I should go look into it before I say that it's ridiculous.
Yeah, well, the answer has to make sense, right? I know,
There
I
is
know
a
the
device
anomalies
called a
that,
pendulous
listen,
vane that is used
yeah,
for
there is a-
self-leveling of gyroscopes.
Yeah, okay.
Yeah, so you should go look into that.
How is it?
I'm not an
Yeah, I'll look
aerospace
into it.
engineer.
I need
You
to-
are, so you should
listen,
go look into it.
Yeah, I'll look into it. The point is this: I need to see a working model off of it. Just because you made some schematics and tried to explain some gibberish doesn't mean that gets fitted on the aircraft. Okay, it doesn't get fitted on the aircraft. I can guarantee that. It might be a part of the subcomponent, but if you look back in history, it was never there because you never used to do it. There's no need.
So
Because
I mean, like,
fly around-
why would there be diagrams and schematics of something that was never used?
Well, when you have to fake it, you have to make it somehow.
Oh, okay. So this is all just like a fake thing. Got it.
Yeah, of course. Yeah, when you there is many
Okay.
black box
Okay,
systems.
look. I get that your worldview requires that you believe that everything that disagrees with your
Yeah.
worldview is fake. Like I get that.
No,
but like maybe you should just go look into it.
Listen, I believe that there's a lot of paid scamsters over there.
Yep, I'm sure.
PhDs, yeah, PhDs, doctors.
Why don't you just
you get
ask
all kinds
Grok?
of. Well,
How do pendulous
listen,
veins
Grok
work?
is just Grok is like a curator search, right? From the
Yeah,
curator search,
so
I
just
can go
ask
into the
Grok to explain
document.
it to you.
No, then I'm going to use that link to get into the document and read upon it.
Yeah,
I don't
so
need to
just do
listen.
that.
Yeah, that's fine. I'll do it. But you see, the point you're making here about a gyro, it is so ridiculous in the face of it. And I cannot even imagine, I cannot even fathom the extent of precision that you're asking off of it.
Wait,
when
hold
you
on. To be
cannot
clear,
even-
the pendulous vane, it doesn't use like the wind speed from the outside. What it uses is it uses gravity to open up various slots.
Oh, there comes another one then.
I'm
So now
explaining.
you're
I'm
telling- you- so
explaining. I'm
to
explaining.
explain-
I'm explaining.
Oh, I'm sorry.
It
I'm
uses
sorry, I'm
gravity. Well, so when the gyroscope is not aligned with the downward gravitation, right? It uses
Yeah.
gravity to open
Yeah,
up.
I just have to take that. My bad. I'm sorry.
When the gyroscope is not aligned with the vertical, which we can get from gravity, it opens up a slot. And once that slot's opened up, then wind can flow in and apply a force. And that force will realign it until it is aligned. So there's a positive or a negative feedback loop that it uses. It doesn't do some precise thing. It just uses gravity to figure out which of the holes to open up to let wind in, and then the wind applies a torque.
Oh, okay. Okay, nice. So what you just summarized here is this: I have to take a fake concept to believe in
Oh my
another
god,
fake
this
concept.
is so bad faith. It's like exceptionally bad faith. I mean, obviously he was bad faith the whole entire time, but it was like exceptionally bad faith at the end. Yeah, I don't think that he was actually an engineer either. I bet that my guess is that he was a technician with 3 certifications. There's no way that he's an engineer and without like knowing this stuff. But we should end the live here because I should probably eat some lunch, and I need to I have some stuff to take care of regarding a paper that I submitted. I have some adjustments to make. So let's read some super chats and then we'll call it a day, shall we? We have a lot of super chats to go through. So from Normal Boy with this 59 Norwegian kroners, if the object was getting closer to you, then the object would be getting bigger and bigger, but it was only getting higher and stayed the same size. Yeah, right? From Curtis Marsden with the $10, I keep sending you money to say you look beautiful today, but I'm just going to become a member. Just don't forget my sentiment, please. Well, I appreciate that. Becoming a member is a great way to support the channel. From Ari Rez with the 2 New Zealand dollars, why people still think this is a thing in 2026? Because a lot of people just want to feel smart. That's what it boils down to. Okay, I'll put my hair down. That's my bad. I should have been paying attention to the light counter. From Fifth Ave Inc. with the $5, my FLERF cousin told me the sun teleports. They genuinely have some mental block or psychosis. There's no evidence that could ever convince them. So then how do people become engineers? The answer is that they don't. From the Drunk Debunk Show with the $5, don't bring up numbers because they destroy their position. How dare you, Blitz? Yeah, right? Like, you can't, like, I should have been able to talk about mathematics with an engineer. Engineers, they should be good at mathematics, but I guess he took up to Calc 3 and that was it. From Ekipo with the €2, my ears are bleeding. I'm so sorry. From Pumpack with the $2, Christopher Columbus is right, Earth is a pear. JK. Well, maybe it is. From Low Earth Surfer with the $10, that must be why you're an engineer and not a science combo breaker. Yeah, no, that was. I'm sorry to all the engineers watching. You guys are not like him. Oh, I'm going to be done in a few minutes anyway. But thank you. My wife just brought me coffee and a drink, like a protein thing, or like a calorie thing, whatever it is. It's one of these things, a boost, because I have to put on some weight before my surgery. Because, you know, I've lost some weight in the past, which is not good. What was I saying? From the Satora tribe with the $2. Here's your check from NASA. I appreciate that. From Ekipo with the €2. Dr. Blitz, please say Earth is a globe. Earth is a globe. From Holy Gore with the $2. I'm paying you, Blitz. See, they're all paying me. All the people watching are paying me. From Vicious with the $10 with a thumbs up. Thumbs up to you. I appreciate you, Vicious. From Nekdu with the $2, paying Dr. Blitz for the lulz. That's exactly why. That's exactly why. You should do it for the lulz. At best, that's why you should do it. From Pat in the chat with the $5, I never would have thought an engineer would numerophobe, but here we are. Freaking yikes. Here's my portion of your income. Well, it's much appreciated. It really is. Yeah, how can you be an engineer and not like math? From Chrissy with the $2, we pay Dr. Blitz to educate people like that. Exactly. See? From Dr. Fudge with the $5, here's your payment for services rendered. Now tell them the Earth is a cube. The Earth is a cube, y'all. You heard it here first. From Eat Some Shorts with the $5, I'll pay you every day to rage bait these people who vote, by the way. Love you, Blitz. Keep doing good. I suspect that guy probably doesn't vote in American elections, at least, because he didn't sound American. I mean, he could be an immigrant, and he could have gotten citizenship, but, you know, it's just less likely. From Normal Boy with the 25 Norwegian kroners, science is fake because I say so. Indeed they do. And from Chris with the 50 Norwegian kroner, hey Blitz, it's us the people paying you. What do you think of the new script? The shouty people are getting wise to the Cavendish experiment. Oh, you can't tell them about the script. From It's Char Not Char, well, thank you for the $5. Dr. Blitz, this is your NASA handler. Adequate performance with that one. Be grateful for the stipend. Get back to work with the next one. Ah, I'm sorry, Mr. NASA. I can't. I have to end the indoctrination session today. From Nektu with the $2, every accusation is a confession. Tends to be the case with flat earthers. It's related to the first law of FLERF. Do we have any? Yeah, we have a few more. From Matt Doherty. Differential equations, if you're lucky. Engineers catching strays on his behalf. Side note, what's a good place for us math engineers who want to level up our math game to learn? What's a good place for us to learn after differential equations? Take a class on partial differential equations, or like you can probably get, like, as long as you know the basics of partial differential equations, you don't need to like take a full class on it, because the thing about full classes is that you'll learn a ton of methods for solving them. But nowadays, unless you want to go into like, you know, partial differential equation theory, like you want to do that like as like a mathematician, you probably don't need to know all of those methods if you just want to like use that as a stepping stone, and then you can start doing differential geometry, you can do group theory, you can do a lot of stuff. From Literally Lou with the $5 Australian, I appreciate you too. Thank you. From Atheist in a Foxhole with the $5, a position is much more persuasive when it is screamed. True. Indeed it is. I should scream more. Eat Some Shorts with the $2, semiconductor gyroscope. Yeah, it's like a solid state thing. I just forgot the word semiconductor, I guess. And from Shane Strife with the $2, just sending $2 my way for appreciation, I guess. I appreciate you. We have a few more, and then that's all the super chats. From Might You Find It Interesting with the $5, he seemed to have held a personal grudge to Einstein. Yeah. So Einstein did marry his cousin, but they were like the same age, so calling Einstein you can call Einstein a lot of things. You can call him a philanderer, because he definitely had strong feelings about monogamy, or strong feelings against monogamy. You can call him infidelitus. He did cheat on his wife at the time. But you can't call him a pedophile. From Pat in the chat, Dr. Gaines. Yeah, we're working on it. It's hard to gain weight when you're on liquids, which I was on for a while. From Al Grimoire with the $2, pendulous vanes use air from the vacuum system. Ah, it's from the vacuum system, not from the wind. I didn't know that. And from Sydney Raptor with the $2 Australian, why are FLERFs so smugnerant? Oh, that's a good word. Because they feel like they need to be. And we got $10 from Grimlock for I pay to tell you to hydrate. Services rendered. I'm not on liquids anymore. I'm on, but like, you know, I was on liquids for a while for reasons. I don't want to go into too much of the details, but for reasons. But now I just have to like regain some of the weight I lost. All right, just double checking, make sure I haven't missed anything else. We did miss a few things. So we got $15 from Matilda for thank you for the important work you do, sending lots of positive energy your way. That was from the buy me a coffee thing. So, and I appreciate that a lot, Matilda. Very, very much appreciated. And I think that that's everything that we got for today. So we're going to call it a day. I have a paper that I have to review, or a paper that I have to adjust in light of the referee report. And I have some other stuff to worry about as well. So I'm going to go take care of that after I eat lunch. I will see you guys tomorrow at the normal time, 9 a.m. California time. I know that times did change recently, but 9 a.m. California time, I'll see you guys tomorrow for some more debates. Take care, everybody.